System jest modularny i skalowalny, dzięki czemu może być wykorzystany w zastosowaniach przemysłowych. Przepraszam. Optymalizuje także przewidywanie, co pozwala na przewidywanie pogody i cen. Zapewnia też także analizę danych energetycznych oraz raportowanie, co pozwala na przewidywanie, kiedy należy jakieś poprawy stosować. Na tym slajdzie znajduje się uproszczony schemat całego systemu. Pokazuje on połączenie EMS-a z resztą urządzeń. EMS podłączony jest przewodowo z inwerterami, z magazynami energii, jednym dużym i jednym małym, który używany jest jako rodzaj UPS-a. EMS pobiera także dane ze stacji pogodowej, co jest istotne przy sterowaniu trackerem do paneli fotowoltaicznych. Na przykład w trakcie jakiejś wichury można ustawić je do bezpiecznej pozycji. Komunikacja z tymi trackerami odbywa się przez protokół bezprzewodowy LoRa. EMS ma także możliwość do komunikacji na zewnątrz przy pomocy protokołu GSM. Korzyści z EMS-a w projekcie POSTEN to ograniczony koszt energii dzięki strategicznemu wykorzystaniu zmagazynowanej energii, podniesienie efektywności energetycznej dzięki rozkładaniu energii z paneli voltaicznych w czasie, lepsze planowanie zarządzania energią dzięki narzędziom analitycznym zawartym w oprogramowaniu EMS, lepsza kontrola zużycia energii dzięki monitorowaniu przepływów energii, redukcja wpływów na środowisko dzięki efektywnemu wykorzystaniu paneli fotowoltaicznych i wykrywanie anomalii dzięki zbieraniu komunikatów z różnych podzespołów całego systemu oraz przechowywaniu ich w danych historycznych. W tej tabeli przedstawione są technologie używane przy tworzeniu oprogramowania EMS. Kolejno przedstawione jest technologie wykorzystane w części po stronie klienta, następnie języki i biblioteki wykorzystywane po stronie serwera, później bazy danych wykorzystywane w projekcie, język i biblioteki wykorzystywane do analizy i przewidywania, biblioteki służące do wizualizacji, protokoły komunikacyjne z różnymi urządzeniami w całym systemie i na końcu przedstawione są technologie związane z uruchomieniem oprogramowania na serwerze. Teraz pokażę parę zrzutów ekranu przedstawiających interfejs użytkownika. Ten ekran przedstawia dane związane z panelami. Tutaj podział jest na dwie tabele. Pierwsza tabela przedstawia dane dotyczące wysp, a kolejny konkretnych paneli. Istnieje także możliwość podglądu danych historycznych z konkretnej wyspy czy panelu. Tak właśnie na tym ekranie widać przykład podglądu danych historycznych dla konkretnego panelu. W tym przypadku wystarczy podać przedział czasowy i można wyświetlić wykres mocy w czasie. Tutaj widać na ekranie informacje na temat przyłączy SFET. Tutaj na tym zrzucie ekranu przedstawione dane na temat magazynu energii, takie rzeczy jak stan naładowania na przykład. Tak, system MS będzie miał możliwość przewidywania produkcji energii z paneli fotowoltaicznych, co będzie jednym ze źródeł informacji pozwalającej na efektywne planowanie cykli ładowania i rozładowywania magazynów energii. Tutaj na tym lewym wykresie przedstawiona jest przykładowa prognoza
That would be with months. So this shows the use of the transmission lines for the exemplary PVs, and the final would be the overproduction, which is in red, in time for the full use of the electricity. The EMS would have also access to the day-ahead market. That's the example. We have the prices of the electricity in time with, and as you can see, the differences could be really high, the spread is high, so due to this information, the EMS could have the priorities of the transmission of electricity with regards to the... Thank you very much. Thank you very much for the presentation. We could see some slides on the system that integrates all the elements of Posten, manages the electricity management, and then sending by the wireless line to the consumers. Do you have any questions, concerns, comments to this presentation? I have one question then. Have you foreseen any maximal number of lines that EMS can... Is there any limit in there? Or we're saying about number. Is there a number? Nope. We don't have any limited number, no limitation here. Of course, the very first line will be created, but it could be added for further. If you don't have any questions, and I would like to ask, is there a film? This is a promotional movie. Maybe let's have a look at a promotional video prepared for an easier what the Posten actually is. With sound.
Dynamiczna transformacja terenów pogórniczych wymaga racjonalnego podejścia do ich zagospodarowania poprzez świadome i ekologiczne działania. Eksploatacja węgla spowodowała powstanie zbiorników wodnych, które dziś stanowią szansę rozwoju energetyki opartej na fotowoltaice pływającej. Wychodząc naprzeciw oczekiwaniom społeczeństwa oraz w myśl zielonej transformacji, rozpoczęto realizację projektu Posten, którego głównym założeniem jest wykorzystanie zbiorników wodnych poprzez instalację pływającej elektrowni fotowoltaicznej z trackerem i magazynem energii. O wyjątkowej innowacyjności projektu świadczy możliwość łatwego przenoszenia farmy do innych lokalizacji, nie tylko dzięki zastosowaniu jednoprzewodowego systemu przesyłu energii, ale przede wszystkim dzięki jej lekkiej, modułowej konstrukcji kompozytowej oraz kontenerowej budowie pozostałych elementów systemu energetycznego. Rozwiązania te, w połączeniu z nowoczesnym, rozproszonym magazynem energii, znacząco zwiększą efektywność, trwałość i ekonomię projektu, a możliwość podłączenia do istniejącej infrastruktury energetycznej pozwoli w pełni wykorzystać zgromadzoną energię. Projekt POSTEN to krok w stronę zielonej transformacji i nowoczesnych, ekologicznych źródeł energii.
So let's go to presentation number 2. This will be not only for electricity, but also the operation of this power station and servicing as well. For presentation, and Mr. Bartoszek, who will present the first. So Veronika on the mechanical aspects and Dr. Bartoszek on control. Weronika Rasińska and I on KOMAG. I could like to present the POSTEN project from the use of the system of trackers implementing in floating photovoltaic power plants. So the PV farm will allow us to bring back utilization, and then we don't use the investments. It is also because they operate in a lower temperature. The efficiency drops down lower due to the water cooling. Then we can use also the reflected. They could use the reflected beams, which improves the gain of electricity. The trackers, they are the systems that allow automatically track down the movement of sun. We can optimize We need to remember, however, that they are more complex. So we'll check if this is technically and economically justified on the PV panels. In order to compensate the costs. So the trackers, we have then orienteering mechanism and also the used system that I will tell you later on. Then we have the high responsibility, like ferns, for example. We will have the increase of the volume that moves the piston, for example. This use they don't have any, and its time is very prolonged. That's why would we have the active main mainly systems. They are more expensive, but they allow us for control by the operator and the precision of the reaction as well. The horizontal that allows us for east and west, but those double axes, they have the scope in two axes only, and they give us and the best solution for. But this, they are the most expensive. It's difficult here. Once we have, but the ones, this is a kind of a compromise. Because they have, everything is there. But they are less expensive than this double axis. And this is what we're going to use in our project. So then I would like to present what we have here. Two scenarios. As in Posten project, we're having also the panels that are there constantly, and we decided to use those elements, the frame and the floaters, to implement in order not to have additional costs. With a motor reductor on a site, however, here we have photos, and then we're having the elements for the bearings for the shaft with the motor reductor. So then there is a relatively high drive weight, and we have this one axis, one shaft mechanism, up and down, long drive shaft. So the element here is just one element, one block. So we cannot have any resynchronization. It's outside of the scope of the whole, which is safer due to the service, of course. But it generates also the bigger size of the whole vessel. We need to have an access for servicing. So that's why we decided to give up the motor reductor. So right now they are below the panels, and it gave us the possibility to eliminate the bigger size. And we it also we have the lower mass and the cost of the drive. So we are here. The assembly of everything will be quite difficult, and the biggest disadvantage is the fact that we need to synchronize. Then we didn't change. We decided to have only the mechanisms. In the previous scenarios, we had one long shaft. And more flexibility here. It was quite problematic there. In order to make it more easier, and these are our solutions. That would be everything from my side. And now the control systems, Dr. Bartoszek. So in the beginning, I would like to start from the systematic information on the PV panel. As we know, this angle should be to it's a generation of the high electricity level, so that's why it's good to use the trackers. That the gain of the electricity should be as big as possible. This is up to the geographical for south and outer Poland, but this angle, as a matter of fact, it's good. The angle is from 35 to 40 degrees, but then if we are to generate more electricity in the winter, then we should have a bigger angle. But if there is to generate more for the climate, for example, for the air conditioning, this angle should be lower than. The other aspect is the way of assembling or erection of the panels. So we've got two main configurations in southern direction and then division into parts and east-west. If we are to the south, it generates more electricity, more energy, 10-15% more than we have the east-west direction. But the energy peak and less electricity in morning and could be not a very good solution. So that is why a better solution would be to have an east-west configuration. When the curve is more flat, it makes then a better use for the profile of most of the consumption, but seems to be more justified because but if we have about make more electricity, to have the more possible, a bigger amount of electricity, but then we can have also the if we have the optimization of the installation, then it seems to be more beneficial here. For control level, we're having here two possibilities. The control in the open loop by the astronomical calendar, or the closed loop with possible with no feedbacks that uses the additional with feedback here. In a closed loop control, it makes a better solution for the beams, and then the gain over will be bigger. However, this is only some percentage more. But this is a more complex solution then. And a bigger cost as well. And but for the open loop, it's a lower gain. However, it's compensated by the simplicity of this lower cost of installations, but mainly also the lower auto consumption of electricity. The trackers they'll be controlled by. So it's mainly the logical also the wireless. But then the actuators, they're having the controller about, and also the alert stages. It gives us a better control. Also the detection of unexpected emergencies. So then we can see the electrical diagram of the connection. It will be supplied by panels. In the tracker, we've got the buffer system. It enables the control of trackers. Also in a situation where the panels do not generate the electricity, like for example during the assembling or disassembling of the panels in the morning, the afternoon, during servicing works, or unexpected situation, weather-wise. It can also happen during at night. It will be the local controls. They will be adjusted by this installed in the system EMS, which is on board. EMS will decide where are the panels right now. For the EMS, we've got the weather station and the internet as well. For the algorithm, for the astronomical calendar and updated, could decide about the panels. Then for the communication, the system EMS and the control system of trackers is going to be a LoRaWAN. LoRaWAN it's got a characterization of the transmission in kilometers. However, what it says, this it's got a topology, a star topology, so that would mean the end and final equipment, they communicate with servers and later on by the internet with server application. In a proposed solution, the structure will be closed. So the trackers will be communicated by the gate with the system EMS. So the algorithm will make it based on the data from three sources. First of all, basing on the date and the calendar. Then the data from the weather stations in order to find out the strong winds when it's necessary to disassemble the installation, but also information from the actuators about the condition of the works, the state. But the local controls by trackers, they will operate they will be automatically controlled by the panels. So what presented but this situation, they control the panels. As Veronika said before, these are the platforms with the trackers, with or without them, but also the possibility of optimization of the algorithm with the biggest possible efficiency. Thank you very much for this presentation. And an important system, it plays the role not only of the bigger efficiency, but also some aspects of safety, servicing of this installation when it has to go there, and then do you have any Thank you very much. How to stabilize the elements? How they could be stabilized? So they will be then but this is a different consortium, different partner, so I'm not able to say anything. So today about this system, it's foreseen the composite system. So it's foreseen for this cooperation between those platforms. Have you foreseen, so where do you come the or if there is any other system? There's an accumulator then in the installation, in the controller itself, on the tracker, in order to cut. We always have the possibility of, we've got a redundancy of the systems. Then thank you very much for this presentation. And the next one. Professor Marcin Zygmanowski.
Prezentacja będzie na temat systemu jednoprzewodowej transmisji energii, zwany SWET, czyli Single Wire Energy Transfer. Jest to bardzo ciekawy system, który mieliśmy okazję go, taki można powiedzieć model sprzętowy, opracować w ramach projektu KLIMCZOK, który zakończył się w roku 2023.
And the natural, then it's a big ticket, is also the preparation of the demonstrator of the solution. And this is an interesting solution, most probably. Thank you for presentation, for the introduction. My subject would be, of the presentation, are the losses and efficiency modeling and a single wire energy transmission for sweat line. I come from here, from So the goal of the presentation would be This is an issue of on every stage of, so we need to know exactly where we have the losses. I will be focusing on the part from the DC, where we have the very first inverter, transformer line, single line and rectifier. But then we have here on every single, we will have then the construct elements if they meet our expectations of losses. Here we have the whole line. In blue, we've got these losses. We can see there's plenty of them, quite a lot of them, and we have them in an inverter, inverter 1. Then we've got also the losses on the earthing grid, and then we're having also the system of the outflow, but of course it is also, but we haven't thought about that, and we don't know what can we expect from there. So the whole line will have 5 kilovolts. This is something new, because in Poland so there was a possibility, this size reduction. Where do we have, what can we be exceeded? Cannot be lower than 10%. The analysis of the losses here to have, we can decrease, we can have limit the losses by the development of the process, but it can be too expensive to extend it. We need to have a look at of those things as well. Also the fact that the efficiency should be above more than 6 kilowatts. We need to remember many elements here wasn't defined yet. But I would like then its structure. We have different solutions here, like the passive power or reactive power. So this is the reactive power with the 10 kilohertz. So this reactive power should be minimized as well, because this is exactly, it will generate the losses as well. To have it in a local that guarantees the low losses of the capacities. We know that it will be checking there, but
warunkach, ponieważ przy zmniejszeniu mocy może się okazać, że właśnie te moce bierne będą się pojawiały i one będą odpowiadały za zwiększenie strat mocy. Co prawda będą to mniejsze straty mocy niż w warunkach znajomych, ale one obniżą stratę. Tutaj jest pokazany taki przebieg napięcia, niebieski przebieg, prądu czarny, przebiegi, jakich należy się spodziewać w takim obwodzie rezonansowym. Żeby przesłać
so in order to send 100 kilowatts with
falownika 750 V, prądów, jakiego się spodziewamy, będzie miał amplitudę na poziomie 10 amperów.
it should be 110 amperes. This is 150 amperes of the efficient power. So this is a parameter here, like the impedance from, so we can find out that this impedance characterized cannot be higher than this is needed from
Ale jeszcze chcę pokazać, jakie związane z tym są konsekwencje. Mianowicie
the consequences are
pracować z układem rezonansowym
we want to work in with the 10 kilohertz, and this parameter is also limited by the parameters we can see that inductivity in our system cannot be too high,
przekroczylibyśmy ten warunek impedancji charakterystycznej, a pojemność może zwiększać się, im będzie wyższa, tym ta niebieska krzywa związana z stałą częstotliwością przełączania rezonansową, ona pokazuje, że możemy właśnie jakby tutaj w obwodzie rezonansowym pojemnością spełnić dwa warunki. Oczywiście w rzeczywistym układzie my mamy bardziej złożony obwód rezonansowy, mamy
then we're having
dodatkowy wpływ
additional line, but here it will be here responsible for generation of some reactive power that can be compensated. So we have the possibility, as long as we don't have the transformer.
Teraz tutaj chciałem pokazać po kolei już w tych elementach, z jakimi możemy się spotykać z stratami mocy. W falowniku. Falownik będzie zbudowany z tranzystorów MOSFET z węglika krzemu, tranzystor na 300 amperów, 1200 V w obwodzie DC. Rezystancja jego przewodzenia
The resistance is 6.5 milliohms, and
kształt prądu, jaki przedstawiłem, spowoduje, że straty przełączania będą wynosiły około 150
this is 150 watts
tranzystor,
for a transistor.
strat przełączania, ale w całym przekształtniku będzie to 500 watów
It's gonna be,
watów w stosunku do 100 kW stanowi 0,5%.
this gonna be, we know that this will be just an inverter of 0.5% of loss.
Kolejne elementy.
So then we've got,
Dławiku i w transformatorze. Mamy
then we have the inductor inductance, winding resistance is high, and we know from HIT 2 an inductor when it was built a very similar system by the line of the HV and high frequency, and then the works there, we had 7 kilowatts there, but basing on those solutions we know what we lose to what kind of transformers we use, what kind of inductors we use as well, and then we know exactly that this transformer and the damper will be 10 times lower resistance of the windings, and then that would mean that the losses in the inductors and conductors, an inductor is going to be 0.9% of the whole capacity, whole power. The next element, these are the losses connected with so-called, we should have 301 inductor and one transformer, so then it's gonna be for sure the big challenge in order to lower. So these are given basing on the heat. So the losses in the course of the transformer will be dominant here. Because we have the not up to the power. Then we've got the line, sweat so-called. In this line, we should have the current, we expect the current about 20 amperes. So 30 amperes, this is 900 times 1 ohm, it gives us 900 watts. So we can see that if this is, we've got 900 watts. So this line is foreseen, which is quite a big, 35 elements. So we've got the parameters here. This is 1 ohm for 50 kilohertz. So we have foreseen here 2 ohms per kilometers. So one can see that with 1 kilometer here, we can see that 800 here, but for 1 kilometer, this would be 1.8%. So this is the best possible material, which is half solar from the microchip. So we can most probably 350 plus ones with the RNC 450 because this is the number of transistors there, and diodes should be there. It's 450 watts, as we can expect. All the losses here, excluding the earthing switch and earthing grid. This is just the starting point. We know that we cannot exceed it, and we will maybe 4%, let's see. That we're having the earthings here. And as far as I remember, the resistance was, they were a bit higher, so of the earthings, so most probably this is an important thing to find out even better parameters than the ones that in Barbara mine. So then we're having the losses in the experiment. So whatever I showed you here will be very similar to the reality. what we have in the reality. Then, so we can have to take into account this is 6.2% estimated power loss in the sweat system of the rated power, but without the earthing electrodes, the earthing wires. So the element that we need to find out, and this will be the transformer, and the attempt to reduce the power losses 1400s, but maybe less than 1400s. Thank you very much to reduce power losses. Thank you very much. Very interesting presentation with a lot of technical parameters. You need to know that right now we are after the 7 months of the implementation of this, so it shows us the vision. We've got the outline, we've got the very first projects, so we can find out if there are some, but here
Wypływa z tego, że mieliśmy pewne doświadczenia w projekcie HIT. Czy macie Państwo jakieś pytania do tej prezentacji? W takim razie nie ma. Zjawiska falowe. Czy tam już musimy przy tych częstotliwościach, przy tych parametrach uwagać, odbić, musimy się tym zajmować?
Odbicia zawsze występują, jeżeli patrzylibyśmy na pewne zjawiska związane z przyłączeniami.
So if we are there,
Rezonansowy, który ogranicza nam tą częstotliwość do 10 kHz, ja się nie spodziewam żadnych zjawisk falowych.
so I don't foresee anything here.
Zdecydowanie jest
Most probably this is foreseen in
w kilometrach, tak, a nie
kilometers.
setka kilometrów.
Czy tej długości
Myślę, że nie.
So I think yes, no, rather not.
Dobrze, a druga sprawa to rezonans.
To jest ciekawe bardzo.
This is very interesting. Let's see how it looks.
Nie wyjść z tego rezonansu, w sensie, czy układ się jakoś tuninguje do...
Znaczy ja myślę, że takie rzeczy powinny
I think that
być spełniane.
they should be taken into account,
Z rezonansu to będziemy mogli na przykład bezpiecznie, łagodnie obniżyć moc.
that we can reduce the power mildly.
Jednak ten system będzie działał na
So I foresee that this is going to be 0, 1,
i trochę, ale nie będzie to płynna regulacja mocy. Zwłaszcza, że w tej części wejściowej przewidywany jest
that we foresee the energy storage.
Dzięki pracy przy takiej stałej mocy można właśnie optymalizować obwody rezonansowe i powiedzmy one będą naprawdę
And they could be really,
bo ja tutaj pokazuję
because I'm finding out right now these are 300, 500 watts, but the losses of reconnections, they are 0. And we need to take into account the fact that if we have it, very often they are much bigger. So the build of the inverter of 1995, so this is what's shown here.
całości 90% to wynikają z tego, że tych elementów jest bardzo dużo.
Bardzo dziękuję. To jest
Thank you very much.
ważny aspekt, czyli
That's an important aspect.
dlatego właśnie idziemy
That's why we're finding the electrical and the transmission seems to be more complex, but gives a chance to be more efficient.
po drugie ta linia będzie dużo tańsza, tak? Jeden przewód,
It's going to be only one
słupy, na których to będzie wisieć, będą...
line.
Dobrze, to ja dziękuję bardzo.
At the end of the day, it's going to be less expensive. Thank you very much. In that case, if there's no more questions.
Proszę Państwa, przed nami troszeczkę
Then there is some knowledge on
jak ogranicza nas
the fact how are we limited by the environment.
typu projektu. Mam na myśli środowisko nienaturalne, chociaż to też, bo to środowisko naturalne wpływa na te zapisy, z którymi musimy się liczyć. Mam na myśli stan prawa i wszystkie aspekty związane z certyfikacją. Prezentację w tym zakresie przedstawię nam
The presentation will be then presented Mr. Madej from Barbara Bain.
proszę.
is no regulation with regards to this what is concerned with this floating farm. So unfortunately, so we need to find then there are directives plus regulations is that unfortunately we have some selected place here. This is the mine. So we need to apply to that. Then environmental issue. And the energy law as well. What can happen, better than not, of course. Then the new equipment, because not everything will be here. So we'll have to be here through the whole process. But then the transmission line will have, because everything, the frequency and the capacity, the power could have the important meaning. So this low voltage directive. And then whatever is connected with the mining law and geological law, due to the fact that it's on the line. So right now we need to have everything adjusted with this mine, and then under the supervision, or it has to be done under the supervision. So then and then everything with a mine, and then additionally with the water reservoir which is there, it would be easier then. So if this is so everything is there in the tank, and there is some activity, but we'll have we need to take it into the water law. So with Polish waters, we'll have to have it agreed. Then additional one with the anchoring that has to be then sealed and tight. So in order not to have their difficulties in the operation of this reservoir or this pond. So then we have the preventive measures and the responsibilities in Wody Polskie and the responsibility of the investor, construction, and then preparation of all environmental So with regards to the both from the mining and construction supervision's point of view, everything is there. We need to take into account all those things. So we will have some problems also with the electricity, water, atmospheric and weather impact. So it's got quite a huge importance here with regards to whatever is then connected with water. We will have to what can we have it here? Not everything could be but if it's not here, if it can be like that in the future, to have something else, then there is some problems with that in the future. Because an impact for the living organisms most probably these are the difficulties. This is prepared. Unfortunately, the presentation is not that beautiful as the previous ones due to the fact that this is just a legal act to be discussed, and unfortunately we need to go through all these and let's have a look what else will be there if we have some details. So this is and here all the time we have a different solution with different requirements. We cannot interfere with the operation of the then additional thing due to the fact that part discussed right now was it was just the production of the electricity and the transfer into the electricity energy, management, storage of this electricity when needed. But then we're having at the end of the day, we've got whatever is there. So there's additional So we've got more rigoristic requirements, and there's more of them than the smaller ones, smaller.
Kwestia organizacji prac w trakcie montażu, budowania generalnie tego wszystkiego, no bo trzeba będzie system KOMTECH zamontowany, kotew będą przygotowane.
Then we will have the floaters and everything, this connection, everything which is necessary for the electrical energy. So then we have to have, then a special attention must be given for the regular requirements, health and safety, because there's water there, so unfortunately, so it has to be taken into account. So there's a problem with this one connected. So the type of the network. With all required employees that will be assembling the things. Generally then, then the documents 10 everything which is connected with the acts here. Mining law, water law, construction law, energy law. Not everything will be there, but quite a lot of important things that will be there, and we need to take a special account, special attention to. So how will we approach it? So I've got a mining law because this is the mining area. Then unfortunately the construction law, due to the fact that as we have the structure we will take into account as well, and then energy law above 1 megawatt, and then additional connected with the new equipment and the EU market as well. That would be most of what I wanted to say. Thank you very much for your attention. Thank you very much for this presentation. This is just a short one, if we are here, if we enter the details, this will be much longer, and I do think that we'll not have any. It will be more interesting of the aspects, of the legal aspects that are very complex. So thank you very much for being in time in 15 minutes. Do you have any questions to this part, legal aspects? Thank you very much. And let's go to the last presentation. The time is up here. The last presentation will be connected to the base, the real base. The base of our floating power station is the structure, the floating structure that we would like to have a very innovative place. The mechanics will have only composites there. In the European scale, we don't have any equivalence what we want to have, so those aspects here that we need to overcome, understand, of course, as well. There will be a lot of them, but as you can see, the scales are 2 megawatts in peak, so it's a big one. We're talking about that big. So it's nearly they're ready for the operational stuff, so we cannot have big mistakes here. So the presentation for SWE. Good morning. As we said, at the very end, we will see everything which is in the beginning of the whole part of our enterprise. So we're having innovative PV panels, which is the floating one, and the challenge, there's always a challenge, especially in this case when we talk about the farms used in water, and then we have the materials that are already there with water, but practically we don't have them. So then in the beginning, my short income, what happened by the PVs. We're talking only about the floating farms. In 2015, it was 70 megawatts. Let's see how fast it is there. It's 8 gigawatts. When we see the scope, we can see that mainly this is Pacific and Asia. Of course, Chinese. And the share here. So we can see with the forecast there, the Europe is going to be a higher share there. But then India is a bigger and bigger player here. And then if you transfer it out, on the companies, with Chinese companies, this is understandable, of course. We also have the French companies, then we have Korean companies as well. And we have two big companies from Germany as well. On the right side is the whole scope, from engineering to... But on the right side, we have the companies that deliver the main elements.
Co my na rynku mamy?
What do we have on the market and why the water, it seems to be, it was already there, elements that it's an increase of when they are water, then
Na stawach rybnych jest to ochrona przed drapieżnikami. Na innych stawach znowuż
sometimes this is
roślinności.
a limited
Są oczywiście i też
increase. We've got also the
związane z
negative as well.
to, co kolega wspomniał,
It is also discussed many aspects,
problemów z elektrycznością,
electricity problems.
To wszystko,
It all, as a matter of fact,
że jednak mimo wszystko
leads us to fact that this is PV, this is a future, and we can see that the water is this element that could be,
szczególnie gdy mówimy tutaj o tych zbiornikach, o tych
when we can see,
tu w projekcie Postęp, gdzie
like in Poston,
właściwie
this is, as a matter of fact, not used for the recreation.
jako taki duży nieużytek. Jak to wygląda generalnie? No tutaj
What does it look like for you, just to have a look? What does it look like?
w jakiej skali to jest?
What's the scale?
Rozwiązania
So we've got the dominant
śródlądowych. Jeziora, osadniki, tak jak tu widzimy po prawej stronie,
as you can see on the right side.
gdzie jakiś typu osadnik. To są tego typu rozwiązania. Pojawiają się rozwiązania
So we can have the PVs also for
i morza, o dużo bardziej skomplikowane,
more complex and more.
no są dużo większe wyzwania i problemy konstrukcyjne. Jeśli się spotykamy się z
So then we have some solutions
o których tylko tak naświetlę, żeby
that just to let you know
z czym się my mierzymy jako
what are we dealing with.
całkowicie nowych rozwiązań. Są to stosowane na
These are used elements,
typu pojemniki tworzywowe wykonane z polietylenu,
polyethylene, tube or rectangular. These are the elements that are
taki modułowy element
a modular element for building
budowy całej farmy.
the farm.
Generalnie to, co widzimy tu w dołu,
What we can see right now,
najczęściej spotykane są tego typu rozwiązania.
mainly these are the elements
Doły i góry.
up and down,
Patrzymy to firmy chińskie
mainly the Chinese companies
z obszaru Azji.
and also from Asia and Pacific.
Część konstrukcyjna, ta nośna, do której włożone są panele, to najczęściej
Mainly they are the steel constructions, steel structures, or the panels
tworzywowych z APD.
adjusted to.
Konstrukcje morskie
We also have branach
w Norwegii, jak już program pilotażowy, gdzie panele leżą bezpośrednio na wodzie.
when they are on the
Główni gracze, jak widać, główne rozwiązania, nie ma tu w ogóle, czyli to są firmy, które
these are the companies that use
albo rozwiązania, gdzie panele leżą
either the panels
bezpośrednio na tych pontonach,
on rafts
bądź pontony
or the rafts.
będące tą częścią wypornościową
This is a part for
starowa,
steel structure and the rafts of with the membrane used in ocean sun, in the ocean with a very limited scale.
teraz tak,
And right now in this project composite, the composite for the heavy conditions, anti-corrosion, anti-corrosive as well.
ma bardzo dużą wytrzymałość,
It's got a very high tensile, a high electrical thermal insulation, which is an important thing with we're in water here. High fatigue resistance. We assume that this is a material durability over 40 years.
kiedy patrzymy na rozwiązania morskie, to zatrwałość i spokojnie można mówić o
So one can say 40 years easily of such an element to be used
stosowanego w trudnych warunkach.
in difficult conditions. So as said before, tested, right now we can see more and more composites, so those solutions yachting, of course, but also motorboats, powerboats, also in railway, bridges, and so on. And then the most important part, why
i w jaki sposób my w tym naszym projekcie chcemy to rozwiązać. Założeniem było przede wszystkim
so most of all,
robić produkt polski.
it used to be a Polish.
Lokujemy elementy, które mogą być
So we've got all the elements that have been created here.
tak, rury,
So the pipes,
doszczewa będzie wykonana z rur
we will have
odpowiedniej średnicy.
the pipes of the proper diameter,
Montażowa, spełniająca tą konstrukcję rur, jak również konstrukcja
and the structure as well to which will have the panels adjusted to. These are the composites as well in the profiles. Then the elements that will connect those elements with
innowacyjny system to ten, że
innovative system is the fact that we minimize the screw connections
przyklejamy do konstrukcji kompozytowej i eliminujemy z paneli
and we then
tą ramkę aluminiową, żeby tą część konstrukcyjną przejęły
we would like to have the structural part
która jest na tej części podporowej. To powiedziałem. No i główne założenie panele
and the main panels. Why
będę powtarzał. Układ pływaków
southeast? Then with the trimaran as well,
trzy główne rury
or the main ones.
są to
They are
pod kątem maksymalnej stabilizacji.
for the maximal stabilization of the system.
Nasze to też założenie
And of course, then our assumption is also that we use here the technology to be used in our structures and constructions as well.
już założenia projektowe. Przechodzimy tego projektu, który już
Then we're using this.
stosowania. Stwierdziliśmy, że optymalnie i to jest już tak wprowadzone do projektu. Będzie to 10 paneli.
There's going to be 10 panels, 5 to east, 5 to west. It shows us exactly.
Przewidywana wielkość takiego jednego segmentu
Then
to 6 na 5 metrów.
6 to 5 meters.
Istotne dla celów
What is important here,
wypornościowych i projektowych. Nie chcemy zanurzać tej rury wypornościowej.
we don't want to interfere here
Letnim więcej jak 40%.
more than 40%. In winter, 95%.
Warunki pogodowe, które mogą spowodować zaciskanie się umowy, kiedy zbiór zamarzałby. Akurat
When we have, most probably, we don't have this problem here, but we would like to have it.
próbować wprowadzać na inne typy zbiorników, czyli ten wymóg, który został nam narzucony, no i my go narzuciliśmy. Maksymalne obciążenie sięgnie
So we have the snow capacity 5 kilometers, 5 kilograms for 1 meter square meter. There are the rubber connectors in order to have the minimum to create some buffer for vibrations and damages due to the wind. And this is it. This is right now the critical element that I want to say more. As you can see, when all the panels, they've been on the plastic elements, buoyancy elements, then the covering by the, it's 95% is covered of the surface, of the water surface.
zmniejszamy pokrycie zbiornika, często jest nawet wymóg, żeby to nie było za dużo.
It shouldn't be too high. Then additional, we have
Ten efekt bifacjalny, czyli odbicie
the bifacial,
światła i zwiększenie sprawności paneli poprzez użytkowanie rury ustawione północ-południe,
then this is of course,
całość założona 25
and 25 years.
I jeszcze jeden, co tu koleżanka,
What was said then,
musimy jeszcze przewidzieć
we need to also have the assembly of the
konstrukcję z trackerem, czyli siłownikiem. Przechodzimy do tej części,
tracker actuator, and then
do tej części, która obejmuje poszczególne komponenty
So most probably there is, say, how it is done. It's also not used in some different solutions. And the further elements, the products that are here, the elements of so on, and the crate as well. For communication, the elements also. Then there's a structure then. So we have the buoyancy, the critical parts, the critical place here in summer and so on. So knowing it, then we need to increase it, and this is their main number. Once we have it here, of course, the calculations, and right now, this is the structure. So there's a calculation, of course, and the selection of the materials. At the end of the day, the whole structure, combination and everything, to have a look where are we and what has to be then reinforced. As you can see at the end, there is a so then we have, right now we're here, and then some information. What then? Only, we can discuss only for the structural part, for the buoyancy, for the raft. Then we'll discuss about the connection, stabilization, everything. This is of course then being, we have works there, but this presentation is not there. Of course, it will be gonna be verified, plus additional inverter platforms that will also float, because the inverters will be there. There will be on the surface of water. And of course, then after the full acceptance of the whole PV adjusted to its shape, and at the end of the day, its stabilization as well. So finishing, this is the end of the fourth quarter, so this is for us the second quarter of next year, and then we can produce this pilot part. So assume that in this part, in this starting part, we would like to have 25 of such systems with full information about, including the tracker, with full information how it will be installed there, all the problems, difficulties connected with that, and later on the stabilization and observation due to the time until we have the full scale of the 2 megawatts of installation here. Yes, so I was a bit hasty because, you know, the time is up and I was hurried up. Ladies and gentlemen, right now we don't have any questions for the next sessions that should have started. I would like to, this is the third innovative mining. But then thank you very much for the participation, for Posten and I will be leading the next session. So I would like to have let's start in 5 to 11. Let's have a coffee break, and then I would like to have the innovative mining in the next session here. Dobry.
No, nie naukowy, tak, prezentacji. Jest tu ta prezentacja? Dobra. A o czym?
O metodach geodezyjnych w górnictwie.
Ja. No, wiem. A ja prowadzę to tak. Szkoda, że nie mogliśmy sobie jeszcze. No, dobra, jasne. Pan ma następnej sesji.
is for
využitia zlož
use of the
nestandardných
deposits here, for not standard methods for detection of the materials, raw materials. Why this research was here? So it's an interesting thing for us
bardzo szybko určiť
to have bulk density in on-site here. Frequently problem in the without the lab. This is the material where we don't need the lab, only to have only this without. So we tested in Slovakia. So it's a perlite deposit, and it's especially for the materials that are heterogeneous deposits. Wherever with the heterogeneous material, that would mean that 30 kilometers could be their bulk density. Yes, which is density actually. We had 3 samples there. One from, it was 18, count the bulk density in lab and also and on site. So what we did before the laboratory determination of bulk density, the tests, and those tests by labs, they are where are we now? A laser we don't have here. Those lithotypes that are heterogeneous is from 1,500 up to 2,020 kilograms for cubic meters of different heterogeneous material. In situ, so we use the geodetical methodologies and had, all the samples with the mechanism of bagging, and then, so we then weighted them on a scale. This is a system how to the volumes in different places, location, in situ bulk density. The minimum 2,000 kilograms, 20 kilograms, with 20 kilograms of the accuracy. And this is it when we had those density and loose bulk density, when the scales and the way, the vehicle weight, the total weight, sample weight, and then we had the type of measuring instruments and the type of the sample as well. Then this place was scanned by a scanner, also by the photogrammic methods, and we made the sample volume, and then out of those data we had how many kilograms we had for the sample weight to have the average bulk density. Then we had the control measurements by the photogrammetry. This is the same methods by the cameras also. It's a comparison of the scan methods and photogrammetric methods. There are some minimum differences, 2% actually. There's a difference between photogrammic and methods, TLS and the terrestrial photogrammetry. For the purpose of determining loose bulk density, it was necessary to determine the volume of the loosened mineral raw materials from the large volume samples. For this purpose, the material from the large volume sample was, after the weighing process, deposited on a horizontal reinforced panel surface for the 2 separate piles. So this is the calculation of the in situ bulk density and loose bulk density. Then, and then on site, this loose bulk density, this is 1862 and then 1818 from the sample 2. So average bulk density is 1840 for the cubic meter. So then the calculation of the in situ bulk density and lab methods, I would like also that this methodology is very good and very useful in the conditions where we don't have a lab. It is just enough a photo camera or a scanner, then just a car or a lorry, and then we exactly know very exactly what's the volume of the sample of the bulk material. With our conclusions and our calculations, we're having the bulk density right in a lab 1756 and in situ 1840. 4% of a difference between the lab and the in situ, so the on-site, would we use the scanner and the technology of the geodetical technologies as well. Thank you for the invitation. Very short presentation, but very fruitful. Thanks a lot. Thank you very much. Nie ma mikrofonu. There's no mic. First of all, thank you very much that you are very, very brief, because the time is up here. Do we have any questions with regards to the professor? I need to say that there was a funny situation. Professor changed the title, presentation itself. I didn't know for what. He said, Peter, what's the title? I said, I'm a professor. Thank you very much, Professor. And please tell us about the next presentation, the structure, the KOMAG as a shear bulk. So we used to be present Dr. Korski from KOMAG, the bolter miners, shearers, and please, let's be brief. So 75% years ago, when KOMAG was created in Bytom, so not only the machines will be used,
pozwalały gromadzić doświadczenia na temat nowych koncepcji maszyn, nie tylko urabiających.
so it's not only in the beginning, the very first shearers we had in the 50s. These are the ones with the drums, with the freezing, in the shearing methods. So it's got also some disadvantages, and one of the disadvantages was the decrease of so-called very thick assortments, because it's not only, but then the railway wanted to use the thicker chunks of coal, and then of course it was an increase of not linear capacity of those machines, the shearing machines. So then we looked for the solutions, alternative solutions. The very first solution was the shears with a vertical axis of the head, because it was then decided that the most thing would be to have the strength from the wall to the empty space, so which is the like that. We had those headers, front loaders, can see the idea of those shearers with the vertical axis and as well such solution, the very first we had, it was a time when we had the British mining, because it was not destroyed by the war with some surplus. First of all, we had the long wall shearer, Webster. Then we had so it was one header shearer with the vertical axis. It was a solution very interesting because the upper part, it was just the blades, and it was driven by the chain, so it was a very minimized size of the mechanism and eliminated also the dead zone. And then on the bottom there is this screw, a kind of a screw conveyor, and then I would like to show you over there is a special color on which it should go down from the upper part to the long wall shear. We don't know, this machine was there, but we're not sure when it was used. However, later on we had KD1, KD, which is the experimental shearer. We never thought that's gonna be, so the KD1 that was constructed, used. We've got a general shearer that there's also a diagram, and that means it was the beginning of the 60s because we're having the system of the shift of the move. I cannot show it to you of this shearer with the solutions selected and invented in the first in Poland in Famur. Together with not KOMAG then, but then this shearer was there and was Walkiewicz Solutions as well, because first of all we're having the anniversary of the today's KOMAG, 75 years, and then the second thing, during the works executed in the museum in Wisconsin, in Guido, we found this header of this. So we found it out. It was difficult to identify it exactly of the solution, but it is there. We can see it. It's good to discuss this solution. This is the Walkiewicz shearer. It will be then renewed and exposed. Then the second solution also that was used so then we would like to, then there is so the last like that, which is produced all the time, this is 200. That is possible to extend the vertical with a hydraulic. The newest one has the system. Before it was the one using the chain. in order to decrease the dimensions. And then we have KDR1, which is also the experimental shearer that had, instead of the drums here, the headers, there was an idea of the drilling, of course, for having the higher, thick, because the drum, the shearing methods of by the English, by John Anderson, and produced by Anderton, then made to have the trepanner, and there is the whole family developed for many years. They were easy mechanically, however, then of course the shape, then there was additional, that it should be rectangular, so we had a much higher, but you know, then of course we had the same efficiency with more complex. So it was KDR1, so I've got two-directional, but this year it could not have two-directional, unfortunately. In one yes, and second one no. So we had to add additional part. So this is what it looked like. It was produced in some examples. So they've been used in non-existing in Grodziec mine. The parameters, they are not very, they're quite small, they are not extraordinary. And then of course for many years it was the electrical 135 kilowatts, 500 watts. So I would like to know why did we started the mechanical and what was used by the shearers. It wasn't started from the very thick deposits, it was just to eliminate the low density of the people with 1 meter or 120. And then of course it was working, it could operate in the long walls with the conveyors, and it could use also with the mechanized roofs, supported roofs. So we can see them in the cellar, of course. Okay, one. Then they haven't been used, or they haven't been used. So for many years the trepanners was used, and then most probably they finished the mining sooner than we don't know what a KDS, but for sure we have some part. So in Grodziec with a very hard, so we didn't have too much, so we as a matter of fact we built with a bigger KDR2, and then whatever was there,
dwa nie nadawał się do urabiania dwukierunkowego,
for two-directional drilling,
ale
but yes, it was tested also in Polish systems, the trepanner shearers, and it was decided that
nie są w polskim górnictwie
in Polish mining they were not used. We had a different shearing double drums that were for much efficiency. It was a different use
w gospodarce, w paleniskach domowych.
in the furnaces as well, in Polish heating systems. So that's why
Trzeba powiedzieć, proszę
one can say that one thing that we had some attempts for the
rozwiązań, to jest
solutions, and this is it. Thank you very much.
Jeśli mówił, to będę przeszkadzał ludziom. Nie wiem, co z tym zrobić. Nie, jest okej. Tak?
Angielski jest okej, tak? Dobra. Unfortunately, we cannot produce right now experimental specimens then, not only about mining, because they don't want us to produce anything or manufacture anything, this is sad, but whatever. Right now, today, should be TRL9, ready for produce, for man. And this, yeah. Any other questions? Do we have any questions? Nope. So in this case, we can be on time, that would be nice. Then I would like to ask for the next presentation. Mr. Andrzej Bercik from FAMOR. Automation of the long wall systems in mining, implementations of FAMOR, and of course, please be careful with time. Good afternoon, good morning still. So I wanted to present you the companies that are here with FAMOR. 100 years of thanks to which it's more efficient and safer. So in different, they allowed us for very complex projects, and right now 3 of them are quite interesting. First of all, this is just automation of the system of the longwall micros, which is a very innovative solutions for operation of very thin deposits. We've got 3 headers here that goes according to the longwall with the infrasound, which is electrical with the frequency converters in. So this, it's used together with the sections of the mechanized roof support with automated system. And we're having the system, what does it look like? Those 3 main systems. So this automized system of the long wall system together at the beginning of the test, it was 2013. And the test and experience from the mining of Yasmos. And then we've got the implementation of the China Energy, Shandong, Gomalnia. So it was by Shigetai 2020 during the pandemic times. It was a challenge for us because we had to go there and remotely try to start it up, this complex, and it was there. Then in 2022, Bulianta. And then the third one is the for micros for the first quarter of 2026 in Hetzago. So this is a control from the surface in the control room, the whole system. Then we've got the underground controls station and the control on site in the equipment for Hetzago. An interesting thing, this position in micros for in China, it was just a position 1,000 kilometers from the mine. The automized system with the control system of the automized roof sections, and then of course we've got also the conveyor, automatic adjustment of the velocity of the chain conveyors for the feed and the protection system of the cable against the stresses and take out. Here we have the position also of the control room. This is how it goes. The innovative technology with a perpendicular system with the whole system during 1 minute, and we can see how it works, the cycle of buckling of the shearer. The mechanized roof support sections. So the system micros, we can see the photograph, and here I would like to show the short video from the acceptance of this shearer here in Poland, which is the inspection and also the inspection and the acceptance commissioning in China. So the second thing I wanted to present to you is this is the long wall complex for Janina. And this one, this is FS 400 shearer, long wall loader, with a LASK 2 long wall automation steering control. This LASK 2, this is a system that faces the face alignment, and it's got two rows, the face alignments of the shear of the conveyor by all the sections, and then of course also the angle on which the long wall is, so it follows the long wall. Then here we've got the inside of the long wall shearer. It was Australian system that was purchased there. As an interesting thing, it's got F16. It's got the very same system as a horizontal navigation. And the third thing, this automation system that is during the operation. We've got FS400 with a module for measurement of its spatial IMS. Then a mechanized rooftop supports with automation, reconfiguration of the section by section, equipped with the hydraulic systems of Barcont company. And here we've got the section, a standard section with the standard solutions and elements. This is, of course, the emulsion for the hydraulic system is very important. That's why with automatic filter here, 30 sections equipped with this system and electrohydraulic system location, pressure sensors. This is gonna be, of course, we'll have also so there's gonna be two parts will be there, and it's equipped with the so-called inclinometers. We've got 3 inclinometers in one module. With a correction, this is a solution that is very similar to NZG Janina. However, this is the alternative, a less expensive alternative to be foreseen in the future. Thank you very much. Very interesting. We still have the development. Any questions from the room? Dear miners, unfortunately, but it's quite interesting, but for one type, the long wall, we've got 2 different systems, monitoring systems. So usually they are right now. TR. So coming back to the conference here, the subject, so that means mining during the green transition. I wanted to say that we as FAMOR as well, being in the minings, it's not only mining but also manufacturers of the equipment. We decided to approach this tendency, and the approach for this green transition is the Greenevia. So the green road, FAMOR, Elgur Hansen, Polsapukt and Impact Power Technology. These are the companies that are Greenevia. Greenevia, this is the green road. With regards to Elgur Hansen is a manufacturer and distributor of the automation for in Elgur. We're also having the station you can see here. This is a station for the farms, for the PV farms. Large-scale PVs, the farms for industry, and impact means all the systems, electromobility and so on. With FAMOR itself, the green transformation also, it was there already. We are known as a manufacturer for the minings. This green transformation in FAMUR, this was the FAMUR Giro, a spinning off manufacturer of the switch gears and the maintenance of the switch gears, and also the switch gears repair and overhauls. Then we've got also the total wind, which is a servicing installation of the windmills, and of course hydraulic power in Zabrze, when we have, then our colleagues are responsible for finding the market. TR2000 could be treated as a kind of a green transition in the galleries and excavations. There we decided to use our shearers for a different mining than the coal mining. That's TR2000. So these are the road headers, and right now this is just the road headers, a typical road headers mining, and mainly a gypsum, but it could be any other feed, or if it's not a lot higher than 60 MPa. And then the road header, it does not use the ATEX because it didn't need the ATEX inspections. So for the road headers, the main element of this header is the frame in position 6. Then we've got a transportation with the crawlers, 5. Then in the front of the frame, then the 3 we have so-called stool. So this is the star loading table to the chain conveyor, position 4. Then we have the upper part. There is also the assembly electrical equipment. Then 13, there's a fan, a ventilator for cooling of the closed circuit. 14, this is the central loop pump. And then in the front, we've got the spinners there, the arm and 2, and then the head. And then on the upper part we'll have 9. We will have 4 operators cabin. And then 12 will have the belt conveyor. So we will have 7 meters high, 8 meters width, 250 of the arm. So we're having the system, the hydraulic system, electro-hydraulic system with the maximum pressure, 25 megapascals, with remotely and controlled could be. And then we've got 4.5 meters, 4.5 meters wide, with up to 5 meters for the stool. The length of this front road header, it was 17 meters with the conveyor belt. The motors that we're using here, the strongest one is for the cutting unit of the front loader, 260 kilowatts. Then the other ones we have the hydraulic system, 185. And then we're having, from this motor, we have the functions like all of the hydraulic systems of the actuators. And the actuators we're having in the arm, cutter, spinner, table, stabilization of the boiler cabin as well. And the actuators for the control of the belt conveyor. Then, of course, we're having the type of the hydraulic systems of the movement and the pump for the central loop system. So these are also what 2 times 12 for the loader, 2 times 2, then we've got 22 kilowatts for the belt conveyor and ventilator 3 kilowatts. So then with the equipment, it's been to Italy. In Italy, the gypsum mine is already there, second generation. And from the very beginning, we had those road headers, and we wanted to have them so they can see exactly that we had two road headers. We've got the different ones. This was the one which is the first one. The difference between the first one and the second one is mainly with the outline. We are having the stairs, and the second one, they wanted to have more narrow the space, so they are in the front right now. They wanted to have a wider passage there. What they expected from us, first of all, the big cabin for the operator with the full comfort of operation. That's why this is the Forbes cabin. A very big, huge armchair, seat, 2 big screens additionally. It's a cabin filter. The second, due to the different location, they want us to have this modifying road headers, and right now there's a cabin that for the time or it goes down for 300 millimeters, so it's 4 meters 20, and then during the operation it goes up, and the height right now of the cabin is 4.5 meters, so it's 30 centimeters, and then we're having the more narrow personnel due to this by the stairs, moving of the stairs to the front of the road headers. Then the other ones that we'll have still in here, we will have the drill. The drill is here. Also, and both says this is the drill of our own production and drilling unit, and they wanted to have from drilling due to they're having their own drilling methods. They are the sample for the samplings to check exactly the gypsum and the marls and so on, the deposits. And then the other one, this is the belt conveyor, the shape and size used for the feed later on for the material. So this is the belt conveyor. Maybe I'll also talk about the parameters. Then the next we'll have, as we're having the feed or the material, not only they wanted to have, due to the legal requirements for some grants, so this is a line, this is and then we're having everything, the cameras, later on the system of reflectors and so on. So there's one reflectors for the stall, then we will have the chute, belt conveyor, the output, haulage. So the most important here, this is Elgor Hansen Smart Mine. This is a system thanks to which we can observe. So all those parameters that we want to have a look at so we can see here, the control room. There's a small monitor in the cabin. In order to find exactly for the new ones, for the new machines, how to help. So we have the system additionally to allows us for activation of the parameters, visualizations, making some graphs and the tables as well and diagrams as well. So AutoCAD, this is also Algor Hansen with it's a supporting system for the operator. Once it's activated, then the road header it uses for the outline, the out sketch at the beginning. We know exactly, it was showed that the operator does not have any manipulators, nothing. They not operate, and even in that it cuts and then make the output and the haulage loads. This is a screen, the screen is there. It's a touch screen, so at any time the client can change or modify the out sketch. The first road header has 1, the second one's got 6. Now I wanted to show you this one. What does it look like? The operation of visualization due to those two systems. The left side we can see AutoCAD. And SmartMine is in the right side. We can see what's the mode of operation. So we'll have the out sketch and the outline. Once we can see the vision with the cameras here. So the cameras front, side cameras, and we can, from the SmartMine, we can see once we can have the cameras, then the most important parameters, the motors and so on, they could be seen in the panels from AutoCAD and the green circles. So that would be it. At the end, we as a manufacturer of the road headers, our typical road headers AM to the works for also the where we'll have a road header RS100 to the mine in Mexico. This is a copper mine, and we also want to come back to the solutions that we used to have with Fahmor, with the systems of the corridors or galleries to use, for the underground garages like in Spain and in Germany, and our road headers were there. So then we can see also the AutoCAD when we don't need those of the softwares enabling the operator to have the required cut. Also the software or the application for the personnel as well. Thank you very much. We lost some time. However, maybe we could have some questions. As you can see, Rema company, farmer company, in all these appearances, were there any questions? Nope. Thank you very much. And right now, this is the very last object, the utilization of methane from the ventilation air. As a Provam company, Marek Kalitka, Dr. Kalita from KOMAG. So we will have the presented here, and I'm saying at 12 there is a break, so let's be here. Yesterday, during the panels, it was said that in KOMAG, together with in the underground, so I would say about a different, and this is everything here in methane, but on the outlet, when the ventilation air comes out from the diffusers. From the very beginning, in the beginning, I would like to show you the very first results of the implementation of this project. There's a report of the composition of the ventilation air from Polish mines, as you can see, but also from Romanian. Why? I will tell you later on, it will be explained. What then? What's the output of this? So from this report, we also have an important thing. For 1 ton of the output of coal, and in JSW, as a matter of fact, it's 7 to 10. So for PGG, it's a bigger difference here. So this is 15 kilo. So a very good situation. The methane is more than 28. And we're having more or less 3.7 kilograms, much stable. Why would I want to show you this? That's because they showed us how important it is, the utilization of in the most probably there will be a necessity, or we've got 8 consortium of 8 people here. So this is JSW as well. That gives us the data, but also is the object that could be implemented there. Insemex, international system from Romania, the University from Oviedo, and the GIG. So we will have is effective if we meet those 4 criteria. So which is stability
ilość wyemitowanego metanu. Wyniki prac zostaną między innymi zweryfikowane w opisanych
they will be verified later in the lab conditions.
będą weryfikowane w warunkach rzeczywistych kopalni Barbara. Pierwszy etap już badań zakończony.
The first stage already finished and they have been already decided in the summer conditions, and also we're having the winter conditions as well. So we are here at the utilization from 0 to 0.4%. It was an inventory, characteristics of all the shafts. So we analyzed all those shafts. So this is 15 meters, and this factor forecasted of the emission level more than 40 kilograms. Then we elaborated also the universal criteria So the most important is the average emission level, concentration, and those parameters, so the dust level and the water content that determine the systems produced by Deere company. Then with regards to the dust content itself, we analyzed the data by the example of JSW. So with numbers, this is quite stable for all. However, for Pniówek, there is a difference quite huge between the minimum and maximum, very similar to PGG. The second system, we can see here that there is a content for JSW that shows also on quite a stable level. But also Chwałowice mine, as you can see. In every here there is for 100. Then the next aspect so I will not show you, but I will present, of course. We can see here in two diffusers here, thanks to which we could have this for the EPSQ. Now for our analyzer was able to show the fractions of all for the number. We've got the small particles sizes, small size particles. So it allowed us later on for the concept of the system for Deere company. For dedusting, drying by the detectors on inlet and outlet of the situation. With the parameters of 62 Celsius an hour. So ventilator and everything. With regards to the sizes of all the system here, you can see that's 30 meters.
Poprzez odpowiednie zasuwy kierowane powietrze może być albo przez osuszacz, albo bezpośrednio podawane do reaktora.
To the reactor. And in KOMAG, we also have this position for the efficiency, which is for two systems. We can model by that the number of the dust and the system of its adjustment right now. The treatment by the spraying nozzles and gives a special ammonia, so the aqueous dust, water diluted, and then of course the scale of the level of scale adjusted to this 2000 meters, cubic meters of the air. So we used also the dryer absorption, dryer cyclone, and then the whole installations of the supply of this air. Then we also elaborated the system by which we measure the parameters of concentration, the water content, pressure of the air, and at the end of the day, some photographs showing the system, which is in our experimental testing field, with a cyclone dryer on the bottom, in a corner, right bottom corner. We can see also the IPSQ analyzer when we measure the flow, that we can go there and then measure the dust content. Then this is the supply system of the dust and having the water content inside the sprays. So I will not have all the aspects because there's many aspects that are implemented. However, there's that series of tests of those systems, and as I said before, verification of the parameters will be given later on in Barbara Mine. Thank you very much for your attention.
Dziękuję bardzo. Widać, że pan doktor się starał skończyć sam.
Really, it was the high noon
Proszę państwa, przed przerwą
before the coffee break question. As you know, it's on the top, very interesting. The methane removal, it's a different approach. However, of course, we need to develop it because 1 year of the project right now. So 1 year, yes, 1 year. Any questions? Then the coffee break, and then the interreg. Dr. Paulin will be leading the session, but I'm not sure. 15 minutes of a break. Thank you.
Proszę Państwa, teraz będzie bardzo ciekawie, bo
It's going to be very interesting because, as you know, we've got quite a lot of sessions or projects, Interreg, which together with the Czech Republic, with Rivnik also and KOMAG, we are very glad to. They are not in English, but they are in the countries of the. So right now you will have the presentation in Czech, Polish. I'm not sure about. No problem. Ja mam rad cześcinu.
Dwa zdania na temat...
So.
Janku, prowadzę sesję. Chyba chcesz coś powiedzieć do gości, bo jesteś przy mikrofonie, nie? Dobra, w porządku. To cześć. A mógł przyjechać na konferencję, to będzie dzwonić. Także generalnie to się zaczęło...
So generally, this is. So we are here together with Łukasz Adamek. We wanted to cooperate, and Joseph is not with us, unfortunately. And we're here, the partner for Interreg. So first of all, we thought we don't have any more. Tutaj będzie angielski, tak. Bardzo proszę. So of course there's a presentation in Barcelona. So we decided to go to Szczyrk, and this is possible right now. Together, Łukasz, I helped there. Interreg is implemented here. It's 1 year. Together, it's good to participate in the president who is with us, and most probably. So we're very happy to have a vice president from Voivodeship. So he's with us here. Can you hear me, sir? Is it all right? Or not? Okay, yeah, perfect, thank you. So, okay, we've got the Interreg. Right now we'll show you how it's done, what are the challenges, and for the future, if you're interested, then please, I will try to do it with time, and for sure, it's a very good lunch today, so we'll be on time with lunch today, no problem. Okay, good afternoon, or is it still morning? All right, I'll try to say in English then, rather than Czech. So it's better to have Czech. So then, that it was gonna be English, but no. Let me get in Czech Republic then. All right. So this is the activation of a cooperation. Thank you very much, KOMAG, for invitation for the KOMTECH. I'm really happy to be here. So actually, we met with Matek, I would say 5 years ago. The Gravity Society from then. So we are every time with KOMTECH. So right now I'm here for the first time in KOMTECH. I was invited and I'm happy to hear. So first of all, I'll try to prepare the concept of the Interreg concept. So our project means activation of a transgranial cooperation with the concept of so-called hydrogen valleys. So Poland here, in Czech Republic as well, in the eyes, is just one of the most active, and we, Moravian Silesian country here, we also have very similar discussion with Silesia, with the Małopolska region in Poland. So we have other roots there. We've got common roots here. That would mean that we would like to have and develop this thought of having, let's say, the hydrogen valley all over through the valleys. So for the Interreg, maybe you will be motivated for the further projects. Interreg is, as a matter of fact, the concept of that should be help all those areas and regions that are close to the countries and facilitate those cooperation, I would say, to the close to the eastern part. So Eastern Interreg supports in Polish and Czech Interreg. That means all those areas here that we have on the map. So we are here together. We can have partners from all those areas. I would say in case of KOMAG, that this is the part, an example for that. Interreg in this period supports 90% of all the supports of the financial budget, 90% of dotation grants. In Poland is up to 100%. So as a matter of fact, this is very interesting and very interesting idea here. 80%, all right. This we have 5 priorities here, and here we are in the 4th of institutions and institutions for all of us. So one can say that we can also have the universities, of course, institutions that are here together with us, of course, towns, authorities as well. So this is, as a matter of fact, very interesting concept that we can develop together, and we have, in the frames of this contract, let me jump here to the next one just to have a look. Where are we? What are the goals? So what are the workshops? It's a strategy and markets. So I'll be there with the markets. I'll go there later on, so you'll be there with me. So let me say about the Moravian-Silesian cluster, hydrogen cluster. The Moravian-Silesian hydrogen cluster was created. So we've got those triple societies, or we've got this company, private company, the holding, cylinders holding, that manufacturers cylinders, we know the big huge tanks. Then we've got the Technical University of Ostrava and Moravian-Silesian region as well. Moravian-Silesian region. Voivodeship. So right now, Moravian-Silesian hydrogen cluster, we've got it's to meet and develop the partnership. So like in the region and some other regions as well, in the republics of Czech Republic with Poland, the Republic of Poland as well, and cooperate and work together, let's say, as a concept for Hydrogen Valley. So it's actually here Mr. Schwonder, Mr. Strybski from the Polish Hydrogen Valley. So this is it actually here with our region as well. These are the founding members. The members, we became as the transborder sister here, but this project, as a matter of fact, that we're here, activation of the transborder, is a discussion how to make it through the border. So the whole vision and the target, the goal, is a technological development. Of course, that's why we are here. For that, geopolitically, and of course, this is our, let's say, also this is a civilization target. And this is the active participation in the hydrogen economy in the European Union, because this is right now what we're having right now. This is the environment, of course. It's a Green Deal, of course. As we know, I would say it's the climate aspect, not only due to the climate aspects. Let's say this is a political subject, but also we're having the resources, because natural resources, Europe is, as a matter of fact, is a continent with this, let's say, how far we are in the technologies here. We selected that our resources started to be emptied, and for the further development we need to use the resources from different continents, so from Asia, of course, and which is our dependence, and it's always very dangerous to be dependent on somebody. So that's why I would say that this is just a question for us. What will be for the future? That would mean this project. This is a main motivation for us. So there is a project that we presented for KOMAG. Thank you for Rybnik. Thank you for KOMAG that we put it together. And we cooperated on this project because, it's very inspirational, this cooperation. So we created, let's say, 8 workshops. Some of them are here. So we wanted to have, as a matter of fact, the whole concept of implementation of the hydrogen economy to the classical economy or the market as well. So we can see, as you can see here, we've got 6 workshops already there behind us. And right now we will have the last ones, which is the industry and production of hydrogen as well. And then in the beginning, we didn't know exactly how it will be implemented in there. And right now here, it's always present with us. So that would mean, so we'll have a strategy in the beginning, and then we'll discuss about the transportation, logistically we'll discuss about the industry. So it's all over. They are all connected together, so it's very difficult to exclude something from the whole topic. So about the goals of the project, I would say that respectively, this is a motivation. This is that the fact that, as I said before, we've got this social discussions and social roots. Moravian Silesian region has got the high production of industrial production. Of course, this is the most industrial region in Czech Republic. That would mean that is, as a matter of fact, it's a result that it is rich in, of course, like in Silesia or Malopolska, there's coal. We've got quite a lot of social discussions. There is a lot of subjects here to be discussed. So that's this cooperation with Rybnik and KOMAG. It's very close to us that we share those projects. We discuss a lot. It's much better than with Prague, for example, or Brno, the big cities in Czech Republic, because they are the regions. I've got completely different subjects. There are different problems right now. So in Brno right now, they sample wines in Brno, and in Prague they taste arrogance. So right now, we've got a bit of different transformation. So you know that here, of course, in Silesia and also in Malopolska, because actually this is something which connects us a lot. So one more thing needs to be said. We've got also workshops, and we've got the very last workshops, and right then we'll have a different subject. This is on the circular economy, and then we'll have it's in December. It's in Prosinec. Yeah. So right now we will say, of course, from the second thing. In the beginning, the motivation was completely different, but at the end of the day, right now, what the project is there, and we know that we've got a very strong partners in Poland. We said that maybe we could have, as a matter of fact, we would like to have also to be visible on this map, to be here with Małopolska and Silesian valleys, hydrogen valleys, to create something which will be interesting for the further development. So here, they forget about Poland and so on, and so that's why I cannot see that somebody from Czech Republic would like to invade Poland. So most probably this is irrational, or it's partnership. So we'd like to facilitate this vision together, and we'd like to create somehow which is a very good, solid foundation for that, to have discussion through the transborder Małopolska, Silesian, Moravian Silesian. Let's not forget about those regions that give quite a lot, which is the coal phase out and so on. So that's, I would start to say, as you can see. Thank you very much for this possibility to present what we are interested in and what we are doing actually, and maybe I will give it over to Bartek right now, which is the partner. Thanks a lot. Thank you, Łukasz, for the introduction to the project. The project is about to be finished soon, but it's very fluent. I do think that this is very fruitful, our meetings, because the subject of today's meeting, there is a production of hydrogen. So as we know in KOMAG, we're very much interested in and focused on hydrogen as well. And we elaborated and constructed as the very first in the world high pressure alkalis electrolyzer. So by chemically can make we'll have 200 bars of the pressure. In the first, as we said about the genesis and the beginning of this first state, today you will have a chance to see the results of the project that's finished and will be presented by Mateusz Wojcicki. So you're cordially invited. The floor is yours. Thank you very much. Good afternoon. My name is Mateusz Wojcicki. I would like to present the discussion of the preliminary results as an example of high alkalic high pressure electrolyzer. I was mainly part of the high pressure hylyzer. Together I was co-author in the project is Kornel Sierpowski, a colleague of mine. So why do we need this hydrogen for? So mainly the hydrogen it could be used in different areas, and this is for the green hydrogen. We can see this is a buffer in the stabilization of the energy. When it's stored in cylinders, could be used as a product that is right now from the surpluses of electricity by the PVs or the wind farms. In transportation as an alternative solution for the conventional or the battery systems. Then at homes, H2 generally as a support of the central heating systems, but electrical heatings with use of the fuels or mainly as the added to gas, because right now it is possible to add hydrogen to the natural gas. So it's up to us, when we would like to use, and it should have a different clarity and purity. As a matter of fact, with the perspectives and potential market of hydrogen in the nearest future, I would say that will have the huge demand, most probably, all the time. This is the pressure to phasing out, the hydrocarbons, sorry. So we will have today the most important thing and the most popular production is by the reforming of gas, natural gas. Then the climate changes make it possible that it's not right now, it's not a method that is propagated right now, is supported, rather is going for the green energy, so that means from the renewable sources, and here the policy goes to limit the use of coal and natural gas. So from the information that we found out in the literature, we can see that the demand for energy from hydrogen in the next years it will increase a couple of times, and the market of electrolyzers right now is growing. So right now this is the perspective of the medium term rather than the long term strategy. That's why KOMAG started to be interested in having knowledge and their own solutions on electrolysis and electrolyzers. So we focused on the alkalic electrolyzers. So that's what we found up to, which does not have the commercial solutions by far. So we've got the preparatory works and the results have been presented right now. The very simple part was up to 200 bars, but we haven't generated during the electrolysis, but later on. So we're having a very simple part, but the 3 tanks, based on 3 tanks, 2 of them for separators. The other one was, and we had also from electrolyzer 2 for hydrogen, and that was separated later on. So the goal of the very first experiments was our validation of the results of the very first against the calculations that we had. And then we had different problems, of course. We had problems with the tightness. So the very first, because we had the deformations in electrolyzers, so they were not too positive. We can see this is the effect of the leak, one of the electrolyzer. But as then we could have the oxygen 94 and 96%. First of all, high oxygen mainly was measured because it's easier to have and easier and cheaper equipment, of course. Then after validation of those systems against the system, then mainly during this with the temperature, we had a very similar results, like the calculations that it meant for us that we'll continue those works connected with the high pressure electrolysis. The next step was to have the 200 bars together with the infrastructure, all the elements that allowed us to generate the hydrogen with a high pressure and checked our hypothesis. The proof of concept, it was actually we had a hypothesis first, and then in TL4 this hypothesis should be confirmed. So we are having the project first of all, and we had some milestones there and environmental factors or indicators. First of all, it was the resistance to 200 bars and possibility of having hydrogen with such a pressure with 50% of the efficiency of IHV with the power energies in 4.4 ampere for the square centimeter. So it was a matter of fact 10 amperes. So we assumed to have more than 95% of hydrogen, suggested being inspired by calculations first of all, or the results of our first experiments here and tests. For the environmental factors, so it was a reduction factor here taken into account. It was defined as the lowering of the cost below 5 kilowatt hours. And the regeneration factor, it was from the fact that in our solution we wanted to use more conventional materials, and it was about to, there will be here with us together, mainly electrodes. So for the constructional, those 200 bars, I said, this is the standard solution. So decided to use everything, the steel, which is 316L. Then the siphon membranes. So this is a constructional because the other membranes, they are from 10, 20 micrometers. Then we decided 0.6 amperes, then the flow of electrolytes 6 decimeters a liter for the singular in order to flush out the electricity from the gas, and the efficiency, as you can see. So this is the output of half a liter a minute. So it was a test plant, of course. So we never just filled the cylinders, only the system, the high pressure system that we built. And the space we just wanted to fill in with hydrogen. Let me show it to you that with a time schedule, it was 2 stages here. Part of the part was engineering, so it was quite a short one, 1 year only. So many of those subsystems, they were specific from time point of view, and the dates, they moved the time schedule and they extended the time, so it's 9 months for the construction, 3 months for tests. And we had this system in the beginning. I'm not able to show it very well, however, it was created so it was ready for the oxygen and the hydrogen part with no. So we had a compensator of pressure. So there was a different efficiency of the production of the positive end of cathodes and anodes. So in the whole cycle, it's changeable. So that's why we've got a compensator, 2 separators, so they were the regulators of the temperature because we decided to have some cycles in temperature. So this was the model. So this is the pile. We're having right now electrolyzer. So then additionally we've got with not classical connections, but just normal things, normal connectors. We've got 2 separators of oxygen and hydrogen, and as a matter of fact, we had this was a closed system. So that means the increase of the volume caused the increase of pressure and filling in of this emptiness, of this empty space in the system. On the one hand, hydrogen, on the other hand, it was so here we have so we have 2 separators here. So that's a stack, as a matter of fact, and the electrolyzer stack that was right now that used. Here's the stack right now. We cannot hear it here. We've got 2 systems here. So it was used some kind of spacers here. Isolations, because it cannot have any conducting was possible. Separators was made from the very thick pipes together. We had the limiters, the stabilizers, so some kind of orifices here in order to by the stabilization and slowing down of this flow could be there, plus degasifying, and then we had everything here, pipe and pipe. So we had a system together. It was with the cooling water compensator of the pressure. So this is a proprietary information, but we changed the volume right now of the particular chambers, cathodes and anodes, and just pumps out with a high pressure pump, electrical pump. And then let me read the hypothesis that we are having before we started. This high pressure with 3000 bars can have the efficiency of the at least 50%. and then the quality would be more than 28%. Let me only present you one of those graphs from our tests, experiments. During the 80 minutes in our electrolyzer, we had 200 bars of a pressure of the space that we filled in. So that would mean it could be then there. Purity was 98.4%. So as a matter of fact, even better than we expected. And this is with no systems, no additional purification, we didn't have any purification, any burning of oxygen. It's just the pure purity from the electrolyzer. And 63% of HHV, so it was LHE because HHV, the LGV was between 53 and 54%. But it shows us, of course, it meets the requirement and positively validated the results of our assumptions. As far as we know, and the analysis of the literature, this is the highest pressure worldwide that could be done only in the electrolysis without using any additional pressurizers. So we have some different elaborations that analytically this technology has been developed, but never we had any experiments or tests, or we never found them yet. So without any purification systems, this is also a huge innovation. And innovation is more or less that we, during the pumping, we divided the system, which is patented also for the cathodes and anodes. Positive. So of course we had the compensation with the computations of the production of both sides. However, on this level productions, we've got a gas of the higher purity, and of course we've got the electrodes used from 316L steel grade. We haven't tested them for the corrosion that was created there, but of course it will be tested later on. So what are benefits? Let me hurry up here. First of all, this is a mitigation of the use of the rare earth metals, nickel and platinum, that they are covered. And with regards to the estimated cost of installations, from our estimates, this is 2.5 thousand euro for a kilowatt, electrical kilowatt. So this is these are the what we had in the project so far. So on a very low TRL, once we will have optimized mainly it will be copied, then multiplied. Of course, those costs will be much lower. With regards to the operational OPEX and CAPEX, so the declared savings comes from the fact that we do not use any compressors. Those compressors are very expensive, and the use of them consumes a lot of electricity in operational costs, but also investment costs, CAPEX, with their use as well. So with regards to the further steps, we would like to have it simplified. Right now, as we said before, as presented, 8 electrodes are there, 8 electrical cells with 70-80 ceilings, quite a lot of ceilings, 70-80 ceilings were necessary with regards to the planning of the tests, modification of the electrodes for the active. So maybe we'll have more rougher, it will be more porous. So it's rather what will have to be done, because we don't know how it will impact the corrosions that we can have in this electrode. Anyway, most of all, we need to elaborate the system for cleaning of the hydrogen, high pressure also, but because if it's like that, for the use of in automotive, for example, when we need this 4,5L, it needs purification, and this purification methodology or treatment, also the high pressure is necessary in order not to have it depressurized and then pressurized, because then that doesn't make any sense. And then all the steps there, they've been planned for the next projects, but right now 2 of them are necessary for the NEO 3 competition that we would like to together to be written as TRSX to propose the electrolyzer together with the system as well. That would be all from my side. Thank you very much for your attention. Would you like to answer? Would you like to have any questions? Some concerns, questions? I think this was very, very thorough presentation. Thank you. Mateusz told us, because I know why we're there, but maybe why? Why? Because you can buy electrolyzer, but at the end of the day, Mateusz said an example of costs, the cost of the system, how can it be reduced? Then the operational cost, of course, as well as service and so on, repairs. We can reduce those costs significantly. The same with the prices. Please keep in mind that the most popular right now in automotive is 500 bars, 700 bars. It depends on these buses. If we have close to 350 bars, as a matter of fact, we could use these technologies for the gas stations. So they started actually with quite a lot of gray hydrogen. And one of the subjects of today's discussion that we'll make during the workshops, this is correlation with the colors of the hydrogen. As a matter of fact, is there any difference? Nope. From the perspective of the parameters used, there's no difference. But due to the fact of, I would say, there is a crazy situation with the environment. It's absolutely mad. There's a huge impact, not to blue, but just green. However, it's easier said than done, because there is a lot of very good slogans, environmental and so on. But how can we make it? We use a lot of electricity and water. We never thought about that. And if we were with the real numbers, how many liters, how many kilowatt hours for kilogram of hydrogen, where to get it from? They are not that published because they are not very convenient. They are very inconvenient. They are very, when you just face those numbers, then you would see, but you know, what's going on here? Where we go? We've got a lot of gray hydrogen that you could use, and somebody wants to, it should be more green, more environmental, and we overuse the environment because we produce, when producing this so-called green, we'll discuss it later on, Mateusz, a lot of details, but we've got patents for that. We can say, yes, it's all patented here. So it's already, we're developing that. We were some investors to KOMAG after the very first information, but generally I think that the most serious partner would be Orlen, if really they would like to be involved. They have potential, but if they really want to have it, we don't know. It would be good to have this continued with Orlen. Okay, right now the plans on the operation of alternative and the role of Diamo and phasing out of coal. So I would like to involve Diamo company representative. The presentation is already there. Lukasz is coming with us. The floor is yours, Lukasz. Yep, just thank you, sir. So before I start this presentation, I would like to ask you, first of all, this is AI, this is Polish-Czech presentation. Right. Ages. Yeah, Polish is the best. So it's for the AI translation. So right now, I'm not sure if this is the very good Polish here, but there's something there's in Polish, something is in Czech. It'll be in Czech. So right now I'm Volek Lukáš, I'm responsible for the consult. As we are in a technology, I've got a technology. We'll have everything about the technology. I would like to present you our what we have. So nothing technological, but I will show you what demo is actually. But maybe some of you, we have some problems. You've got technologies here for that. So I would like to present on that. In the beginning, this is the Diamo, maybe you know it. This is a state-owned company with Struży Podravskem. So we're different, right? Because we're not private, because we are here state-owned. That's why our main but not only thing is recultivation or rehabilitation of the post-mining areas financed by the state. So we recultivate, we rehabilitate, and this is what we do this is our main activity. Where are we? Diamo. We're in the whole republic, so we are here in we have those here parts, and I'm here from Karvina, of course. So that's why I'm responsible for those regions. But here, this is our headquarters, but also our. So right now, it was created in last year. It was an externalized department that took over from all Darkov, Karvina, Odra, Ostrava. So right as this is new, separated. As a matter of fact, you've got in Silesian, Moravian Silesian country. So as I said before, we have Moravian Silesian. So we are the separate, external spin-off, separated, externalized. So maybe you know that we have a Dino Park in Ostrava. So we are there, of course, we're Karvina, but we have a headquarters in Ostrava. So, but our activity is the whole Moravian Silesian country or region. Together we have different locations and areas. I will show you later on what we are dealing with. So we can see there's many of them as well as the areas that we are here from. There's quite a lot of the countries or regions that we are here. They have their own actions or activities, development activities. So that's what we do actually. But this is just a part of it, of our activity, main activity. I would like to present those areas or those locations when we have our activities, for example, that are one in Karvina, of course, Darkov, also Fredek Mistek area as well. So here we are currently, I would like to show presence of what the cooperations we are having. One of those most important things that we are having right now, these are Tranovice. This is the region of Areal Frenstadt. So it would be very interesting for us because right now we are preparing that, for example, for the works that will have partially is already ready, partially is paid, partially is not for the implementation of their own CRK projects. Those projects will be the center and a restaurant, of course, and there's quite a lot of transformation there. So they have the transformation of this area for the new interesting area. So I would say everything this is just right now. We're in Ostrava, Karvina, so this is the Areal Frenstadt, which is in Trojanovice, a little bit different area, allocation, but still our responsibility. Also Gabriela, so with the colleagues there from our Moravian Silesian country or the region, this is a shaft Gabriela, also in Karvina. And this region will have their own activities. This area will be there for the region, and the region will be responsible for the voivodeship. Actually, will be implement, or the county, I should say. They will be responsible for the transformation of this area as well. Then what are the prepared the areas, the regions that we're still responsible for, and this theoretically we could have used all those. First of all, this is Lazy region or Lazy area location. There's also a Shaft Lazy in mine in Orlova. We are cooperating in there with action of Kostat sales there. So right now together we would like to have quite a lot of a development activity that we would like to have, as a matter of fact, to found this social society and then have whatever it is necessary by the law. The areal representation in it is a strategical area. So there in this area, maybe we could have some additional very interesting things. Actually, this is gonna be. It's gonna be. Let's see what we'll have in the future. How what can be done there, and according to the study, then we will implement, and we will make. These are, of course, the technologies, and we've got to test. Quite a lot of actions must be tested and studied. What can be implemented? What could be done? Then we've got the Areal Cesa. It's a Karvina Dolly. Also the shafts and post-mining area. We'd like to have also in the center there. First of all, we would like to have our own. What Karvina is responsible for. Of course, there's quite a lot of responsibilities and quite a lot of area here. I would like to have the studies that should be here done. This is this part to the left. The Vernon corridor. There's a study that needs to be a modular exhibition for. So let's see what could be used there. Different technologies could be used there, of course. Then we'll have Areal Darkov as well. Then this Karvina part, we also have one very small area, which is Darkov, close to also the Karvina, so-called Karvina Sea, and this area also would like to develop together with Karvina. So I'm going there. This is just for the citizens and for the local societies, local communities. Will be very have to have a sporting area, maybe to have also the rent of, because there's quite a lot of campsites or something very interesting for the lake, because this is a lake area there. Then we've got a bigger one. This is the main one, the Darkov as well. We would like to have liquidate one of the. It's not planned yet. It's 2034. So we have to study exactly to have very interesting area. What could be done there? So it used to be mines, of course. There's that infrastructure already there, and we would like to have complete to use the works to have it as possible as together with the chess area. So to use it in a proper way. Or is it the PV panels or some different technologies, industrial, or let's see what can be possible there. Then we've got also the Areal, the last one, the Areal Stasic, which is a Fredek Mystek area here, and we will develop here very similarly like so this is we'll cooperate together. This is the second area that we presented before. That is also by the strategical in the law. So, of course, this is a phase. Once we know exactly, then we'll go to Stasic. Once we realize the previous one, the strategical ones. And the last thing I would like to say exactly, this is the handling of the mining gas. So right now we're having some works together with. So we have so-called gases, mining gas for Vodik. Right now, in the presence, is a degasification of the plant. So there is, of course, we'll have to, according to law, because there's a law, legal stipulations, take care of those mining gas. All right, so that would mean battery standards. Yeah, should work. Where we don't have the gasification, then what is possible? But then we would like to transform this degasification for production of. Once we meet the legal requirements, we would like to then generate the gas as a product. Thank you very much for your attention. I think what you caught there during the presentation, I also have a question. Something's wrong. Here we are, as you know, most probably. I'm not sure if this is a microphone now. Batteries as well, but this one is right. So Diamo is like this, okay. So very, very similarly to recultivation pipe, to invest there, and we can see the problems are very similar to our problems because our neighbors have the very same lower case. Of course, we have more mines, but very similar. So very similar ideas, and they are very well stipulated. Luca said about the farms, PV farms, of course, the possibilities of having the renewable sources of energy there, because as everybody knows exactly, the infrastructure, mainly the connections, the agreements and so on, high voltage grids, they've got a lot of potentials to have, were built in such a way not to, they were the consumers, of course, of the electricity, because they need a lot of electricity, but right now they should be generators. We've got the technical, but not necessarily the grid wants to accept it. It's not ready to accept it. So we need to work on that as well. Rybnik, I would like to, Mrs. Sylwia Brzeńska, to tell us about the green transition of Rybnik. The city is changing a lot, as I think, then as a result, and the works with our electrolyzer and everything which is connected together with Czech Republic and our Czech friends. Then we'll go to the big next project to have the whole system for electrolysis, gas station, everything, district heat. I do believe that it will manage, but with such partners, I think the partners, it cannot be differently. Thank you very much. Once more, I need also something here. So, I would like to invite you to the town, the cities with a brave vision, bold vision. Right now, the very first slide is not, this is not a coincidence, because you know very well that there are different strategical situations, but until it gives us the goals, the sustainable participation, town or city, innovative leader, and also the town of chances. So I will tell you why we're there. There'll be a lot of boasting, but you know, we will have quite a lot of transformation for Rybnik. From the very beginnings, when we applied for the EU funds, right now we're 1.5 billion we scored, 386 million zlotys, these are from the EU. This is what we are finished 21-27. And then the project that I would like to tell you later in detail, 180 millions, which is the Just Transition Fund. So green energy or green electricity. Then we'll have the support, the financial support. This is a priority for us. Clean air, czyste powietrze program. Rybnik 2 years ago was on a very first position when was the biggest number of applications and they used the financing of the clean air program. Then Mr. Piotr Kuczera decided that we will have also, and to 16 to 18 it was from dotations or grants from right now. This is not that, this is the so-called ciepłe mieszkanie or warm flat. 22, 23. Also we could have the grants for EU grants and the green energy. We are the leaders there and we are the partnerships here. So I will not tell you about all of them, but we have more than tens, but here we've got dozens of them functioning quite well. Rybnik, into the green future. This is so-called soft project.
Celem tego projektu jest takie budowanie odporności i rezyliencji lokalnej społeczności.
So this is the resilience of Polish with the adaptation, but also with the identity of our town and sort of the bond with the history. So we've got the implementation as a town as a leader, because this is exceptional project, because our NGOs are there and the foundations that are there. Salute, I mean we will have support. So right now it is also have seen. So we are here during these two centers, and of course all the time we develop the projects, ecological heritage and the problems, of course. So we will have educational problems as well. So we've got an urban lab that will have, and a very interesting area here would be the regional start and the archive of the green energy. We are the leaders, and Koleszczyny so as a matter of fact, this is the biggest project that we're having. There will be grants. Let's see what kind of scale is that, because this is a project that is in total 260 different renewables and electrical as well for over 170. So right now we are signing the so this is the date, should be. What else is being done? We're having a huge investment, thermal modernization of our so as a matter of fact, we had only a couple of them for full thermalization. Then this is 250,000. So here we are in 2023, but of course the scale is there all the time. I'm not sure how far, what was the year then, but so closing of all for 2 days most probably, and you know it was discussed in media. Here we are 20 days. So the activities, what are there? We are in a partnership. So we're having here, so we've got so-called Przemek project for 20 years. We've got the data collected. A very interesting project, Mistral, with our hospital, when we test the list of, so we've got the carbon in the urine and also in, so we will be there, we'll have this, those tests. We are not seeing the legislation, but we participate all the time because we are here in a council of the project. We are in 2 commissions here and also in a local government and the government. One of the most interesting projects that we will finish soon enough, the green transition. We're one of 6 of the local governments that are in this project. So we've got those innovations that we will implement the solutions that are there, that we work on. Of course, this is the participation of the local communities, of course. We are from, right now, the Rybnik hydrogen area rather than it was before. So we had very good decisions, communications, and we'll have the very first communication and in the future we'll have the 14 hydrogen buses, the next buses. So this is our fleet. What will have the structure for the communication in Rybnik? You can see that 80% this is gonna be the low emission fleet or zero emission fleet. At the end of 2022, there is we had the second in Poland gas station, hydrogen station, filling station. This is what it looks like. We had the opening on 2023. It was communication. Right now, here we are. The green energy, so one of the most important things. So we had the huge grant for the biogas plant in Niewiadom. 22,000 of the bio waste, green wastes, we can see, but only 6.1% this is going to be our own funds. The remaining part, this is the National Environmental Fund. This is just a biogas plant in Niewiadom. This is what it looked like. So we'll be commissioning on 2028 startup. Then the closed circular economy. This is the goal that the Rybnik wants to have. As you probably know, here we are, the ITPO, the installation of the thermal
Parę miesięcy temu
transforming treatment of the wastes.
z naszym miastem podpisały
So we signed also such a contract in the
inwestycyjne
letter of intent, and right now
analizy
we've got the analysis for the streams of
instalacji termicznego
what could be used then,
zlokalizowanego na terenie elektrowni.
which is localized there.
Rybnicki Okręg Wodorowy
Then Rybnik hydrogen area. This is put together with the Silesian University of Technology. We're very happy. The environmental department, so this is where I come from,
będzie
will create here in Rybnik also the renewable start and technologies, hydrogen technologies. These are the four elements. The lab,
laboratorium Ekodom Energia
Economica, mobile lab,
oraz Centrum
and of course this competence center of renewables. And
Jeden z tych elementów
so one of these elements, the visualization, the
na terenie parku
Ecodom energy in the park, close to the center of city center. An important part, an important aspects.
wodorowego to jest również
This is also education and
specjalistów,
the
ekspertów.
specialists, experts in this subject. So here we have the hydrogen solutions. This is something what we have in our school. And then the spectacular revitalization of green transition in Rybnik. It used to be Ignacy, the old monumental, and right now this is what it looks like right now. Everybody uses it, all the local, the complex that was prized by the European prize of the highest rank for the revitalization, and this is what it looks like now inside. So you're cordially invited here, and of course what's planned, that's also right there in Ignacy, a shopping mall with 19 million zlotys. Thank you very much. Thank you very much for this presentation. Yes, we need to, there's nothing wrong in saying, we don't say enough. We have quite a lot of things to be discussed. I'm not sure why, but right now it seems to be very that, this is not enough. Yes, we need to say about that. We need to boast. I wanted to say to the President Gilianczyk because these installations that are created right now of chemical treatment, biogas plant, biogas unit, of course, when all connected, for sure they will have to have the tests. So KOMAG is the very first certified for the, according to the grid code. So the green transition of transformation, I want to say that I was there because in 2016, a very short anecdote here, thanks to my colleague, I work in the municipality, said, Bartek, do you have gas? I said, yes. Why don't you have? Everybody said, no, you will pay a lot of, and you will have cold at home. So I risked, imagine in 2016, it wasn't that popular. Generally, we had the recruitment. I prepared my application in March 17th. Did you know which one I was? The participant, number 3. I was number 3. Half a year. I had this grant, I received this grant that I wanted to go from the, and as a matter of fact, 80% of the investment was covered by the grants. I had lower payments that I used to put for, and next year, we had a very long queues that people, the people waited the whole night. I think this is enough right now. Rybnik hydrogen area. I'm really happy to be here. Right now I would like to invite the next of the potential post-mining brownfields, MSCT, Czech Republic. We have the presentation, so the floor is yours. Thank you very much. Good afternoon, ladies and gentlemen. Thank you very much for the invitation to Szczyrk for all of us. And right now, I will tell you right now in some plan of transformation that I have and the vision that we're having right now of the European between Poland and Czech Republic and Austria as well. So here, let me see. We know that the Moravian Silesian, this is just a peak of the peak of history. There's a potential here behind. Rybnik, of course, as well as there, and Ostrava. The last years, right now, from our regions, we can see we are going north. When we can see there's a dynamic, and very often we can see that you are very, very helpful here, so we are a little bit jealous here. But we have this idea here also the historical, sometimes less, sometimes worse, sometimes good, sometimes bad cooperation. But right now, in the middle, in the heart of Europe, this is just a motto of the Europe, the spinning wheel. Ostrava, Katowice. So most probably Polacks, you are more ahead of us. So we're going here to Biedronka, to Silesia also. And here, we're going here because we have the zoo in Ostrava. So, of course, for the free time spending, and there's a migration. And I think it will be here, this also the economical development here. As we can see here, this is the investors here because we're going there in the middle of nowhere because they don't know what to go there. And then we show the map. When we can see the Silesia here, it is enlightened here. There's got a lot of light. It's not just an empty hole close to the mountains. It's the industrial region, and we can see also the energy production there. Heavy industry as well. We can see it's quite a lot of from the Austro-Hungarian, then to Germany, then communism. Right now, here we are in, and our goal is to have the brownfields to have to somehow to recultivate and rehabilitate them. So there are some locations that we already managed to succeed. In the center of Ostrava, of course, Karolina, Main. Right now we've got a completely new quarter. There's a shopping mall, and there's a new drive. The same, we've got the Dolny Oblast Witkowice, which is right now 40 hectares of different colors of Ostrava. One of the best location in Czech Republic. Nothing less. In 10 years, it will be further transformed because this whole locations will be the developing changed by developers. There will be the festivals and so on. So we'll go in later on. We're going further. Wider context will need everything is there because we can have the huge investors and preparations. So there's also the new tendencies by AI and so on. So we will not be prepared in those areas here. Our colleagues Poland or in the Hungarians, the grants will go there. So this is something where I'm jealous that the flexibility of the process of preparation for it lasts 5-10 years in our country here. So, for example, there are some months in Poland Yeah, but it was very. These are the strategies that we are preparing right now. This is Dolní Lutyně. This is on the border with Poland. Here we are here. There's a strategy that was a pyramid with thousands of hectares of the zones. They are very more than 100, 200, 270 hectares. Regional zones prepared for the public sector. Strategicals, very often Magdotr Wołek, what is already there. These are those areas that are already prepared, and they are ready for, as the examples for the investors, or the strategical ones, because right now this is what they do. So this is exactly like Hyundai or some other investors here. With the synergies with the classical approaches, there is like Panatoni or CCP and the other ones. This is a known zone already, of course, but what we have prepared for the private sector is the preparation for infrastructure for railway, of course, also the motorways and the roads, energy solutions, and everything will have to be prepared for our investors. Also, as well, we need to have railroads, roads, motorways, and dams as well. This is very similar to us and with us. So as we can see, this is very similar to what we have. What is not happening here. So right now the Polish financing for the location. To są fazy, które tutaj się dzieją. So this is what we need to change right now. What has to be changed in Poland and right now this is communicated right now. Ostrava is the mission of the AI town, AI factories in the frames of the European. So we've got the mining universities here, there to be transformed. Right now this is what we communicate as Ostrava. We have the location here in Frydek. With right now the best AI factories right now. We've got these activities in Poland as well, and this is also about the synergy in the frames of this region, how to cooperate together. So we've got the architecture, the building, construction site for energy, water as well, and as well as all the connections. And this has to be done with this alternative sources of the resources. As it was said before, like is it Diamo, so the former mining areas and the cooperation also with the academic world. What we are working together mostly, which is the with Polish, Austrians, also Slovenia, from Gdańsk to Vienna. And our co-partners are from Xenon, Katowice Special Economic Zone. So we are very much inspired by, because Xenon some years ago created a modular park. This is just a subject for that we need for our regions, like the post-mining areas, to replicate them. So I think that in Poland right now this cooperation could be a very good and effective. And then in Austria, of course, we are there, and we are one step ahead, because we've got the memorandums with Linz and also with the southern Vienna and southern Austria, when we've got very similar project and very similar that we would like to have in the European Union as well. And then we're going also to Germany, because we're going here to this is what we would like to have some sight of. So at the end, we have here how to create exactly it. So right now we would like to have something that we would like to have defense sector, or we're inspired by the historical El Camino Real. Right now there is a special, after 50 kilometers they had some center has been created El Camino Real, and this is the most stronger. We've got Meta, Google, everything is there, Tesla and everything is there along the El Camino. So there's a kind of a network and of the development, and we're trying to do it in a Czech Republic, and we would like to have the connected to Poland as well, and Austria as well, the same network or the same line from the south to east. Very effective. Thank you very much for your attention. Thank you. I'm convinced this cooperation will be cooperate because there's more and more entities cooperating. Ladies and gentlemen, as a matter of fact, the time is good. Right now there's time for lunch. There's one presentation, which is my presentation, but I decided to move it. It's boring. No. I'm joking. I will be moved to the workshops that will be have done later on, but in order I will tell you some sentences and some will focus on the potential of the post-mining area from the perspective of hydrogen production. So most probably most of you know about what are in the post-mining hazards. Water is one of the hazards. Among our preparatory works, I make a research, and based on one mine as the example, I don't want to say which one. So I said, what does it look like with water? And I don't think to say that, as a matter of fact, we've got those three geological lines that they are here. We've got so the inflows, and the technological water is used every day for the technological processes when producing coal. So now I would like us to know together, to tell us, because this is a danger, this is a hazard for the existing mine, for the production of coal, miners and so on, and it's not closed. This water must be there pumped out. The flooded area and everything there, all the situations are there, but how to do that, to have from this, to transform in the potential, hydrogen potential, and already now, just the numbers from the artwork. The number of the pumped out water in a minute, 3,000 cubic meters a minute. If you calculate it by hours, by days and years, we'll have 2 million liters of water. And what happens to it? Mainly, we will have the desalination system. Then it's desalined. It's treated. We've got salt that could be used, and the water goes to rivers. If we decided to use this water and this line to produce hydrogen, we know that for the 1 kilogram will see 13 liters of water, and this water would be there. It will be salinated, but due to the RO, it could be used. And I'm of the opinion that this hazard of water and its potential to make the hydrogen, but not only hydrogen, because the whole line that could be used could have to look for water. First of all, the drinking water, potable water. We know exactly that water is right now the treasure of, and the battle for water will start because the potable water is less and less the resources, and if we can manage what we have, the mining waters, and then treat to such a level to have a potable water would be nice. And then don't do it with water, because it will be the most stupid things to have potable water and to transform into water. But not everything could be used for water. So then, as a potable water, we can purify it, treat them, then create technological waters, and then separate for the water. Hydrogen, also technological hydrogen, could be used at different. But what is then oxygen? Oxygen is needed for the hospitals and so on. It's not that easy that we've got electrolysis, hydrogen and oxygen. It's not this grade of oxygen, but it could be enriched, could be purified, treated, and to use this oxygen. Most details and examples I will tell you later on during the workshops, but right now I would like to invite President of the Mr. Skipski to let us know what are the feeling or hydrogen valleys, where are we, or are they, and Mirek then, what are they missing in order to be prosperous? Good afternoon again. My role today, I'm the president of Silesian Lesser Poland Hydrogen Valley, the biggest hydrogen valley. What can I say? Those valleys, so-called, they're stopped. Now it should be 5, it's 11, and for 2 years, luckily, we don't have any more. But for sure, the financial means came. So the hydrogen valleys are needed for the country to meet some role. And today, as a matter of fact, the most important are, the most valued are so they are better. They're but also in Lesser Poland we are there, where in metal there's more and more, there is quite a lot of awareness that the role of the hydrogen, because we are here, it's not only creation, the fertilizers, but also we're having some different locations, but we need to learn it. We've got the specialists, we know a lot, because we produce quite a lot of it. But like this is like with the decarbonization, that right now it's not so that the gray could be used in the valleys. We say no, only the green one. So there's a lot of ideas that cannot be implemented, because Rybnik could not have the buses if not that they guaranteed that this hydrogen that they're having, this is the green. And for me, this is one of the biggest barriers that we're having. This is going to be difficult, even if the potential is to usually Rybnik will confirm that once something started, it's very nice. Bartek told us about his. There's so many interesting areas, and water is, as a matter of fact, an important thing. Lunch is coming. Thank you very much.
za te dwa zdania. Ja muszę powiedzieć, że Dolina Wodorowa, w której też jesteśmy członkiem tutaj jako Instytut, ona daje duże możliwości nawiązywania współpracy i to jest jakby kluczowe, bo relacje trzeba budować, tak, bo suma summarum wszyscy chcemy mieć tą wartość dodaną. Także zachęcam do zgłaszania się, do zapisywania w Dolinie Wodorowej, na pewno to nie będzie dla Państwa stracony czas. Nie poruszyliśmy jeszcze jednej
So there's one thing
to odpuścimy, ale mówimy o aspektach technicznych, technologicznych, przemysłowych, ale wodór ma bardzo duże znaczenie również w medycynie i w zdrowiu, bo generalnie my w naszym organizmie mamy sporo wodoru, a jak go mamy za mało, to chorujemy. I nie wiem, czy Państwo...
I'm not sure if you are there, if you know exactly, generally, that the therapies, hydrogen therapies,
bardzo korzystne, bardzo mocno wspierają walki z różnymi chorobami, nawet tymi najcięższymi. Więc jest też ta rola...
so there is also this role.
kwestia energetyczna i przemysłu. No rybnik ma zielony wodór, a przynajmniej butle są zielone, więc to jest ważne. Najważniejszy jest obraz, a nie co na tym obrazie jest. Szanowni Państwo, bardzo dziękuję za tą sesję.
So terribly sorry. Thank you very much for this.
Wspólnego zdjęcia.
Then common photograph and then lunch.
Dziękuję, życzę dobrego, smacznego obiadu i dobrego popołudnia.
Te oryginalne.
Stwierdził, że wyszliśmy jak murzynki bambu i nie chcą nas, czy da się nas bardziej doświetlić, nie wiem, te lampy tutaj zapalić u góry
Dobra, to ja tam
statywem. Byłbyś tak
sprawdzam.
miły nam pomógł. Będziemy bardzo wdzięczni. Jaki celebryta, takie zdjęcie.
wonderful project which is coordinated by our institute. Thank you all, everyone who joined this session. We hope for more people to join us. The timing is not very good because we are just after lunch, but we hope more people will join. We will have 6 presentations during this session. First will be presentation of myself, which is overview of the project, and the follow-up of this presentation of myself will be 5 other presentations focused on specific results and ongoing works in the project. Project is titled Ecological Rehabilitation and Long-Term Monitoring of Post-Mining Areas. This is research project co-funded by European Union under the Research Fund for Coal and Steel. The project started in the middle of 2023 and will last until the end of next year. The total budget of this research project is almost 3 million euros, and we have 11 partners involved in the project from 5 different countries. From Poland it is KOMAG Instytut, PGG, Polska Grupa Górnicza, Poltegor Instytut, Główny Instytut Górnictwa, Państwowy Instytut Badawczy. From Czechia we got our partner WHU Institute. From Greece it's Technical University of Crete and Public Power Corporation. Corporation is industrial partner responsible for a big part of energy production in Greece. From Slovenia we have Premegownik Velenje, PV, another industrial partner. And from France, partners involved in the project are institutes and laboratories from Bergem, Ineris and Valoris. So regarding the project, this is very multi-dimensional project, very interdisciplinary project. It actually could be several separate projects, but the general goal is to build on existing knowledge and experience of post-mining rehabilitation approaches, to propose procedures for accompanying the transition of coal mining areas while considering ecosystem rehabilitation and monitoring future intended land uses and affordability of solutions. So what we do, what we've done already, we assess and catalog existing knowledge and experiences on post-mining areas rehabilitation approaches in different European countries. We developed already and tested new solutions for post-mining land reclamation, and some of the presentations will focus specific solutions, specific products and specific technologies. We are developing, and now the monitoring is ongoing, we are developing tools for efficient short-term and long-term monitoring of post-mining areas rehabilitation. Also, another topic is development of certification method. It is related to audit catalog that we are preparing. There will be also a dashboard to help managing reclamation processes. It will be developed as well. And also we want, like now, to share the knowledge, to disseminate, to present you our results to the variety of stakeholders from different groups, from industry, from public, also from scientific area. So chosen results so far. So first of all, we prepared a framework for classification of degraded areas, post-mining areas. We also developed a tool, so-called impact matrix, to support decision making while managing post-mining area rehabilitation and reclamation. We developed method for controlled, for steered succession of low-growing plants. We developed non-contact soil remediation technology. We developed a product which is compost and the technology for soil regeneration by using the compost. We are working on monitoring tools and procedures, as I mentioned. We are working on European audit catalog and on dashboard, which is
intended to be a customized visualization tool. Some of the results, for instance, this one, we developed the methodology, the impact matrix, to assess vulnerability of post-mining areas to climate change. There are several factors included. It is open access tool available on our website, so you can take a look and see if it's useful for you. Also, in one of the work packages of the project, we decided to choose several experimental areas in Poland, France, Czechia, Greece, and Slovenia, of course, in order to test our solutions that we developed and also to perform monitoring activities in these areas. From Poland, it is post-mining area, a heap, hard-hole heap of PGG, and also post-mining area in Konin, lignite basin. So, regarding one of the results, which was the development of directed succession method for revegetation of post-mining terrains with high redevelopment potential. So, GIG, Central Mining Institute, they developed the soil improver, which is created from municipal waste and the material from hard-hole heap. They also developed the seed mixture, and altogether, and application of those two, it is a method to steer the succession on post-mining heaps. Another major results of our project is the technology for non-contact soil remediation and control of soil parameters with use of bio-wastes. And the main part of this technology, of this system, is the spraying device, which is developed by KOMAG, our host today. It is really interesting. They performed several tests on post-mining heap in Jankowice Północ, which belongs to PGG, and the results are promising. Details will be presented by Dominik from KOMAG. Another result, as I mentioned at the beginning, it is very multi-dimensional project, so we got different results. Another result that intends to support soil rehabilitation is compost of high biological activity developed by Poltegor Institute. This is interesting product because it uses lignite waste, low caloric lignite, which is a waste. It uses poultry waste. It's in terms of feathers and also straw. So we would like to commercialize this product. We ended our tests. We are in the process of calculating feasibility of this product, and details will be presented by Ania from Poltegor very soon. We applied our compost in several areas in order to check if it influences the soil properties, but one of the other potential applications of compost is its influence on metal mobility from soil to plant. Some interesting tests are ongoing in France, in Mazingarbe post-mining area. Another category of our results, so we developed the let's call it a toolbox for soil monitoring. We defined and we summarize multiple biotic and abiotic parameters that should be taken into consideration while monitoring the soil conditions in post-mining areas. We also summarized all the potentially useful remote sensing indicators that could be used. We developed self-organizing maps for the purpose of large-scale and long-term monitoring. And at the moment we are in the process of implementing this monitoring in several areas across Europe. So here are some of the sites. Maybe I will just name them. In Greece, we are focused on post-mining areas of Public Power Corporation. It's Ptolemais and Amitalion lignite mines. In Poland, as I mentioned, Jankowice Północ HIP and Konin lignite post-mining area, specifically Jóźwin-2 B external dump. In France, it's Mazingarb, a very old post-mining area. In Czechia, these are two dumping grounds, two hips in Most lignite basin, Radowesice and Strimice. And also very interesting active mining area in Velenie in Slovenia. And regarding the audit catalog that we are preparing, here you can see some graphics. The intention is to support the whole process of management of reclamation. In parallel to this, we are developing the visualization tool, which is a dashboard to help to visualize this process. And the details of development of these two tools will be presented in one of the presentations later in this session. Our next steps are mainly focused on commercialization of our outputs of the product of the project. So I mentioned at least 4 big results which have potential for commercialization. At the moment we are calculating feasibility of it. Also it worth to mention that products that we develop, which is compost and soil improver, it's kind of a bridge between industries because it uses circular economy, it uses waste from other industries. So it might be also implemented potentially in other industry in order to reduce the cost of waste utilization. Here you have some QR codes. I invite all of you to visit our website and social media, which is X, LinkedIn and Facebook. You can easily find us by Googling Recall. The KOMAG created the website, so you can add Recall KOMAG and you will find us. If you want to collaborate with us, please let me know. I have some business cards. I can just leave it maybe here. Please feel free to ask questions to me, to ask questions to my colleagues who will be presenting. I can see like half of us here are from the project, so the other half, please ask us the questions. Thank you for your attention. From the perspective of coordinator, we got a really nice team. The results are promising and there is a big potential for both commercialization of results and also continuation of research in other projects. So if you also have ideas how to continue our research or how to improve it, please feel free to share the ideas and we can think of another proposal for a research project in upcoming years. Thank you very much. I will maybe take a seat. I will be the one who will introduce the next speaker. So we kindly invite, or maybe questions, if you have some. If something comes to your mind, feel free to contact me after the session. Okay, so let's invite Ania Chońska-Pulit from Poltegor Institute, who will present the presentation on technology for soil regeneration by composts of high biological activity. The research was conducted by Ania herself together with Justyna Sobolczyk-Bednarek, Dominika Kówka and Amelia Zielińska from Poltegor Institute. Ania will give the presentation online. Ania, the floor is yours. Hello, hello, Ania. Yes. Yeah, Anya, we cannot hear you. Oh, yes. Now we can hear you.
Okay. Can you see me and hear me?
We see only the not the full screen presentation, but it's still okay. Okay, now it's full screen.
Okay, so I can start. Dear CEOs, my name is Anna Chońska-Pulit. I'm biotechnologist from Poltegor Institute, and I and my colleagues from Poltegor would like to present you our research study for task 4.3 of recall project, technology for soil regeneration by compost of high biological activity. And we have already entered this task in August this year. And I would like to summarize obtained result and show perspectives for our products. In this task, we produced compost from three materials: from waste feathers, from poultry industry, from straw from agriculture, and we used also low-rank lignite. And we turned these three ingredients into a valuable resource, compost. And this practice is aligned with European circular economy model. Compost offers many benefits for the soil. For example, it promotes microbial activity, supports the establishment of diverse plant life, and it's a very valuable product. Soil degradation in post-mining areas is connected with many problems like loss of soil fertility, disturbed water retention, acidification, erosion, and reduction of microbial activity. And we think that our compost with high biological activity can address many of these problems. So we prepared in Poltegor 500 kilograms of compost, and we tested, and we and our partners from Ineris and from Slovenia, we tested it in 3 case study areas in Poland, France, and Slovenia. So it was 3 transitional coal regions. And we also, our partner from KOMAG tested compost solution involving a spraying device. Our way from laboratory to field lasted 2 years. First, we had to characterize soil in Konin. The soil was sandy with poor nutrient value and low microbiological activity, so it needed reclamation. First, we provided composting process in laboratory scale. It was small scale with 2 kilograms of biomass. And on this stage, we tested bacterial inoculum, and we have chosen the best variant of its inoculum for composting process. Then we scaled up process to semi-composting scale. We used in this process two kinds of bioreactors, static and dynamic. You can see them on the right photos. We prepared also instruction for compost application based on obtained results. And also we take into account, of course, Polish and European regulations. And then prepared compost we applied in Konin, where we were monitoring soil condition and maize growth. Here I would like to show you analytical methods which we used in our work. Chemical analysis, especially mineral composition, heavy metal contents. We assessed also microbiological parameters and biochemical analysis. The most important enzymes were the hydrogenases, which reflects the microbial activity. And we've made also standard physical-chemical analysis. The very important aspect is in our work is compost inoculum. We prepared this inoculum. Firstly, we isolated bacteria from compost substrates, feathers, lignite, and straw to degrade them. And we achieved 3 strains with special abilities: Bacillus metylotrophicus, able to straw degradation; Streptomyces fulvissimus, which degrade lignite in biosolubilization process; and also Bacillus altitudinis, able to feather degradation, feather, a main source of nitrogen in our compost. I would like to describe also tested criteria which we choose for evaluate compost efficiency in terms of its biological activity. I have chosen and showed here selected parameters. So we monitored in compost, for example, temperature. Our compost achieved thermophilic phase, very crucial for composting process. We studied chemical fertilizer value and heavy metal content, and our compost met all criteria described in European regulations. For organic fertilizers, we achieved compost with which was maturity, as you can show, maturity indicators are on desirable level. Also, biological activity was very high. The hydrogenase activity was 16 units, which is much more than our target value, which is less than 1 unit. We tested soil before compost application and end of vegetation, and according obtained results, I can tell that compost led to increase in concentration of 3 key elements in the soil: potassium, magnesium, and phosphorus. We also noticed that compost application led to increase in the hydrogenase activity in soil. And field test with maize. Compost application provided to higher shoot length in maize plants. It was 15% increase in comparison to maize which raised on control plot. Also, germination percent was higher in case of compost treated plot, maize compost treated plot. So we have valuable product. I would like to say a couple of words about dynamic of compost production and market. So in European Union, European Union is experiencing increase in bio-waste processing. 1/3 of the bio-waste is used to produce compost and biogas. The organic fertilizer market size is expected to reach even $13.6 billion by 2029, and number of composting plants in Europe is about 3,800 facilities, the number that is still growing. Mineral fertilizer consumption in Europe, our competition market, fell over by over 20% between years 2017 and 2023. So this trend is very beneficial for compost, but because it makes niche for compost, for our product, soil amendment, which is more ecological friendly in comparison to mineral fertilizers. And at the end, I would like to say about our competition on the market. So on Polish market, we can distinguish two compost products, compost inoculants, which like Bicompost and Compost 2.0. These two products contain bacteria, selected bacteria for compost inoculation to accelerate composting process. For example, because contains the Bacillus strains, and Compost 2.0 contains Micromycetes. And second kind of product is typical major compost, like our compost. And here I would like to show two compost made from plant wastes like compound and pokinnek, and one compost made from animal byproducts, similarly like our product. And as you can see on the table on the right, our compost product is very competitive in comparison to other preparations, especially in case of nitrogen content, but also with organic matter and phosphorus and potassium. Summarizing obtained results, waste streams and lignite have been transformed into high value and effective product, soil compost, which is soil amendment, which can be used also to soil regeneration and also in agriculture. Developed inoculum process supports soil's microflora. Our microflora added in form of inoculum acts not only in compost, but it can act further after compost application, so it is kind of soil probiotic. The obtained compost product, as we showed, is competitive with other similar preparations on the market. And the next step will be cost and benefit analysis, which will be carried out as a part of task 4.5. Thank you for your attention.
Thank you very much, Ania. It was very interesting presentation. Me personally, I like the most the last part regarding its potential for commercializing. Our results are not public at the moment because Ania will probably apply for patent on this product. If you are a mine manager, environmental engineer, or you are anyhow related to post-mining area reclamation and you see potential of application of it at your reclamation efforts, please feel free to contact Ania directly or me. Do you have any questions to Ania? All right. So now we proceed to the third presentation of this session, which is technology of non-contact soil remediation, which will be presented by Dr. Dominik Bałaga from KOMAG Institute. And the research was conducted by Dr. Dominik Bałaga, Dr. Michał Ziegmun, Dr. Mateusz Wójcicki, Dr. Marek Kalita from Instytut Techniki Górniczej KOMAG.
Thank you very much, Marcin. Good afternoon to everyone who joined us this session of Recall Project. I would like to present you a result of our work in KOMAG, which I work as an engineer, about technology of non-contact soil remediation. Something to change slides. Yes, what's about? We at the KOMAG developed a new technology of the non-contact remediation, technology which is based on selective and automatic dosing of reclamation materials, such as mulch with seeds, bio-waste or water. Everything depends on current soil condition and environmental factors. We have to say something that this technology is mainly focused to support and complement other reclamation methods. It's not the solution for whole waste heap, for example. Of course, I would like to share the information that we made the application for Polish patent called Device for Contactless Soil Bioremediation with a number you can see on the slide. And the most important thing you should know, the solution is made of two most free. It's built of three basic systems. First system is UAV with multispectral camera, which is a vision and decision system to collect images for vegetation index analysis. Another subsystem is called a soil monitoring system, which is some kind of measuring station, which give us data from soil sensors. And the most important element of this technology, automated spraying system, which can apply our reclamation media, as I said, mulch, water, fertilizer, etc. The vision and decision system is based on unmanned aerial vehicle, which has multispectral camera to record images, which make it possible to generate vegetation index. An operator interface for the automatic seeding system was also developed, so together with a decision system application. This application helps to choose which area should be seeded based on data from monitoring system collected by the UAV platform. And the second one of the subsystem is as I said, monitoring system. It's integrated with the environmental monitoring unit, and it can be installed on a surface of the waste heap. It has an independent power to supply it, and has a GPRS communication module, which can send the data to our system. So the monitoring station allows continuous recording of key meteorological and soil parameters, important for our effective reclamation. The most important for us are soil temperature, moisture, pH, and humidity, air of the humidity, air temperature, etc. And the third subsystem, as I said, the most important, is automated spraying device, which is some kind of set of machines and devices configured to apply different reclamation media, water, mulch, seed, bio-waste. And it's built of spraying cannon, pump with unit suction, IBC tanks, mixers, power generator, and also compressor. As I said, we designed it and we, of course, built it. We built it as a prototype to carry out the first test of the system. First tests were carried out in laboratory conditions, and after that we were ready to get to waste heap, where we have our test plots. How the technology works. First of all, we are having data from soil sensors and photos from drone, which we are collecting and analyzing. Based on this data, we are making some kind of map of reclamation treatments. For example, we are preparing seed grass together with mulch, adding compost or bio-waste, and watering the surface to keep the right moisture level at the area. And after that, we are dividing area into small fields, plots, according to the range of spraying unit, and each field is assigned a center point using GPS. And for each field, we prepare some kind of scenario, a special control file, which is uploaded to the system of the automatic spraying system. And the automatic spraying system is then moved to the GPS point and perform the planned actions. After the treatment, continuous monitoring, of course, we are still carrying out. If the soil sensors of or from measuring station and NDVI index are showing something wrong in the parameters, we are making a new scenario and new treatments. Okay. Oh, this is some kind of example how we can do this. This is example test field in Greece, which we recognize some fields where we should do, for example, some kind of treatments, water, bio-waste, or mulch with seeds. And for all of those points, we prepared. Sorry. Oh, it's not showing. We are preparing some kind of files which allows us automatic work of the automatic spraying device. As I said, we built it and we tested on the waste heap, Jankowice Północ, where you can see the automated spraying device, which is mounted on the vehicle. You can see here soil monitoring system and a vision and decision-making system in the air. You can see here, I'm not sure it works. Sorry. No. Okay, so we, as I said, we tested it on the waste heap. We made a few trials and tests where we confirmed a full technical operability of the system. I'm not sure why it's not working. Okay. And what we achieved, of course, we achieved a very high effectiveness of covering the surface of the waste heap with bio-waste and mulch mixed with seeds. And the most interesting information is that we reached about 95% vegetation cover in the reclaimed area with the first month after seed applications. So this shows that the technology is ready, of course with some improvements as always. So we are still in progress to determine how much bio-waste and mulch needs to be applied to get best reclamation effect. Of course, I have to say something more about what we found on the waste heap. We tested our technology because we found there also spontaneous appearance of plant species typical for natural succession. So this the presence of these plants shows the substrate is able to self-colonize and reach biological stability. It also confirms the role of mulch as protection against erosion and as a factor that helps create niches for native species. And of course, their appearance proves us to that our developed technology can work synergy with natural processes, speeding up succession and increasing ecosystem biodiversity. Thank you very much. If you have any questions.
Thank you very much, Dominic. It was very interesting presentation.
Thank you very much.
The system itself is impressive in my opinion, and it still has a lot of potential for further development, for commercialization. So if any of you see the potential or are interested about the details, interested in cooperation with KOMAG, please contact Dominic. Another presentation will be given by Dr. Łukasz Pierzchała from GIG, Główny Instytut Górnictwa, Państwowy Instytut Badawczy. He will present presentation titled Rehabilitation of Hard Coal Heaps by Steering the Succession of Low-Growing Vegetation. The research conducted together with Dr. Marcin Głodniok.
Good afternoon. I would like to present a little different approach for post-mining reclamation. The methods combines the rehabilitation techniques with natural processes of spontaneous succession, and the main co-authors of this method is Dr. Marcin Głodniok. Okay. At the beginning, I want to describe why rehabilitation. It is with definition. This reclamation techniques is different from approach which aiming to restore the state before degradation. and it focus on this to achieve the best structure and environmental values on the impacted area. So it taking into considers the state that we current have, not trying to rebuild it, but set the solution which gives the best benefits and the greatest ecological value on this change condition. Regarding the steering, directing, or also managing succession, it is a process of reclamation when we subsidize the processes which appear spontaneously on the degraded area. The requirements is know how this process is going on. You need to understand it and use in reclamation processes. Natural succession on this point heaps is connected with very difficult habitats for vegetation growth, because the plants have to deal with dark materials with high percentage of stones and gravels. It is dark. It makes that during the sunny conditions the temperature is very high. There is lack of nutrients and shortage of water. So the plants which appear on these habitats gradually have to improve the condition for grow, and it takes a lot of time when these vegetations are able to appear there. For example, you can see the surface of Sośnica waste heaps, which where the spontaneous successions processes last for 10 years, and still you can see the lack of coverage of vegetation of this on this terrain, and also rapid encroachment of woody vegetation is appear, which could cause some problems, especially risk of thermal processes especially on hard coal waste heaps. What is the goal of our methods? It is we wanted to develop dense vegetation cover dominated mainly by herbaceous species, which is able to compete with invasive species and also decrease the encroachment of woody species. So it should be low-cost methods for greening spaces covered by waste hard coal mining, and we set the aim that the vegetation should be developed directly on the waste heaps surface without creating some layers of fertilize of native soil or other fertilized layer. For example, humus layer or other soil substituents. The soil plots was placed on the flat part of the Sośnica of Północ waste heap in Jankowice. It is the part of unreclaimed part of this waste heap, which accommodation stops 2 years ago, and here we place the experimental plots, but also the control plots. We decide to develop the fertilizers or soil improvements which will able to support vegetation growth by deliver available forms of phosphorus and nitrogens for vegetation, and also it should improve a little water retention in these difficult materials for vegetation growth. Here you can see the impact of different doses of these products for physical chemical parameters of soil, and you can see that different doses increase the availability of phosphorus and nitrogen, and also it in some part increase the water holding capacity on the waste heaps material. Then we provide the test using synapses alba growth, and based on these results we choose the appropriate dose of fertilizers to in situ application. Also, the part of this method, we decide that we apply or will dose the seed mixture on the surface of waste heaps to deliver species, native species, which is able to grow on waste heaps, which occur spontaneously, which have low requirements to biogas and water conditions. And very important, the seeds should be availability and low cost for pursuing them. This is the examples of species that we use. It is mostly common weeds which also are flowering and deliver the nectars for the insects. Finally, 20 species of herbaceous plants and 5 grasses were selected for preparing the reclamation mixture. In situ experiments were carried out in this year, at the beginning of this year. We apply the fertilizers, and after 1 week we also saw the mixtures which seeds. Here you can see how we dose these fertilizers. It was done manually. The area of the study plots is 40 meters by 40 meters. Also manual methods for sowing and raked was applied by all these techniques that we use could be mechanized using standard agricultural equipment. So it is able to provide reclamation on wider area. Just after our fertilizers applications, some native species appear, but it is rather not the species that we put there using our mixture, but it is spontaneous succession. So it gives information that the species could get there very quickly, and not only desirable species but also invasive species could appear there. So it is very important information, because it means that the application of techniques that cover the area should be carried out as soon as possible to decrease the risk of spreading invasive species. Some results, for example, in our experimental plots, highest number of species was observed compared with untreated plots, where there also some species were observed, but rather the species appear there and in a short time. Yeah? Sometimes it exists only a period of time, and after droughts or wave heaps there disappear. But also reference ecosystems have a lower number of species. It is because we apply the sowing and also some spontaneously species appear there. Of course, also some contribution in invasive species we observe on the experimental plots, but also in spontaneous succession. So it means that leaving these terrains for spontaneous succession makes some risk, and it is not the best solution for post-mining reclamation. That is the also result for the first season, vegetation season. You can see that the cover of vegetation is not full, it is about 30%, but it was also this vegetation survive the waves of heats and droughts. We didn't observe the decline of vegetation cover. A lot of new species and plants appear during also the autumn. So we predict that in the next vegetation seasons we achieve higher contribution of the vegetation cover. So currently the graduality colonization plants introduced with sowing and spontaneously appearing on the waste heap confirm the effectiveness of our reclamations approach. The increased organic matters content and availability of nutrients enable to vegetation survive during the periods of heat and droughts. We expect, but also plan some additional treatment to increase the coverage in next vegetation seasons. And firstly, this methods was developed to areas with high redevelopment potential for temporary vegetation greening this area, but we see that it could be also used for areas with some nature and recreation potential, because the contribution of flowering plants makes that it is attractive also for recreation and deliver some ecosystem services. Of course, we use the wastes which cause a problem with utilization, so it is in line with principles on circular economy. This way of thinking could be applied also to other degraded area. We try and evaluate the effectivity of the fertilizers to other degraded soils in mining area from our partners, project partners. So if you have very similar problems or you see potential for application this method, we are open to cooperation.
Thank you very much, Łukasz, for your presentation. Time is money, and the methods developed by GIG can speed up the process of natural succession. As Łukasz mentioned, if you are interested, feel free to reach directly to Łukasz. Thank you very much. If you have any questions now, please ask. All right. So we move to the fifth presentation of this session. The presentation titled Assessing Soil Refunctionalization in Post-Mining Area, a case study from a Greek coal mine, will be presented by Olivier Hulot. The research was conducted in a big group of people: Stefan Bojwin, Makary Musiałek, Łukasz Pierzchała, Emanuel Varohakis, Julie Gontant, Valerie Bert, Ekaterini Servou, Christos Rumpos, Marcin Maksymowicz and Jennifer Harris. Please, Oliver, the floor is yours.
So this work is a part of the Recall project, especially the work package 5, focusing on monitoring short and long term of post-mining area. As we know, we have reduction of mining, coal mining extraction, maybe led by European unions, and the impact of mining activities, current and past mining activities, led to irreversible damage to the environment due to soil excavations, soil transportations, coal exploitations, and waste storage. Okay, so after the stop of the mining activities, mining areas are generally classified as degraded or highly degraded area, which imply a reassignment to another use for the future. And as Lucas said previously, an ecological rehabilitation is not a restoration to an ecosystem to its pre-existing conditions. So to achieve this transition, an ecological rehabilitation is the most promising way through an improvement of physico-chemical property, a regeneration of biodiversity on site, a restoration of ecosystem functions, and after that, a restoration of ecosystem-associated services according to the future use of the site. So to evaluate this rehabilitation success, we need to monitor ecological soils associated functions as the first brick of the rehabilitation process. The 6 main ecological functions are store and convert carbon, store and filter water, provide nutrients for biocenosis, regulate contaminants, support biodiversity, and support soil structures. And most of currently available indicators can directly monitor soil functions, but monitor ecological process which supports soil functions. And for that, we have record all these indicators in the one of the recall deliverables, which is the definition of soil functions monitoring toolbox. Classically, to monitor soil functioning, we use a field-based approach, which consists in mapping of rehabilitated area, the definitions of soil collection point depending on specificity of areas, and after that, in situ analysis or laboratory analysis based on soil samples. This method requires a high density of soil collection points. It's costly and time-consuming, and results can always be easily extrapolated, which make these solutions not well adapted to post-mining areas. We can cover wide-size areas. The remote sensing approach, based on UAV or open satellite data, can monitor large areas, such as post-mining. However, the monitoring is indirectly linked to soil health and mostly based on environmental conditions and plant health. So in the Greek regions, we we develop a project to optimize the monitoring of post-mining soil by combining biological, physical chemicals, and remote sensing data in order to effectively assess the restorations of ecological functions. This is the rehabilitated site located in the Ptolemaic mine, which two non-rehabilitated area, one as control and one as a starting new rehabilitated area. Two area with annual crops, we are 2 fields of barley, and 3 area with perennial crops, 2 in Norcad plots with apple and cherry trees, and 1 in an acacia forest. Based on the first deliverables of work package 5, we choose some soil health indicators, mostly enzymatic activities, microbial respirations, and soil organic carbons. Other was measured but not presented today. And concerning the remote sensing indicators, we base on NDVI data. And for each sampling plot correspond to 2 or 4 NDVI pixels. To assess refunctionalizations on soil-based indicators, we do not interpret directly each indicators. We perform normalizations of data from 0 to 5, 0 corresponding to the meanest value and 5 to the highest value record for each indicators. And after that, we perform a score of refunctionalizations for each functions or a global score of refunctionalizations. To assess refunctionalizations through remote sensing indicators, an average NDVI score was calculated from the end of April to end of September to have a representative way of soil health plants during all the growth periods. So, firstly, regarding the field-based monitoring indicators, we can see we have a gradient of refunctionalizations from 1.27 to 3.68. And this gradient of refunctionalization score corresponds also to a gradient of refunctionalizations, gradient of vegetations along rehabilitated area. The second part is the remote sensing value, and as for the field-based indicators, we have a gradient on NDVI, which is also observed along a gradient vegetations, even if the control parts correspond as the same NDVI score than the barley crops. And after that, we try to link NDVI score and refunctionalization score. Firstly, for individual parameters, and we observe quite strong correlations for some indicators as phosphatase activities linked to phosphorus carbons or microbial respirations, while some enzymatic activities like alpha-glucosidase and aryl sulfatase were not linked to NDVI. And the strongest correlations were found when we recreate scoring functions score, which indicate that we can really correlate the health of plants and soil functioning with 3 most of the 6 functions, which is provide nutrients for biosynthesis, support biodiversity, and store carbons. These results are really promising to combine field-based soil indicators with remote sensing indicators to improve the monitoring strategies of large post-mining areas. The next step will be to validate these correlations in more homogeneous environments in order to strengthen the reliability of remote sensing as proxy of soil health with KOMTECH will start next month. And in the long term, such approach can support large-scale soil restoration programs and help to achieve European objective for soil protections and land restorations. Thank you for your attention.
Thank you very much, Olivier. Are there any questions to Olivier at this point? Very interesting presentations. As Olivier said, the research is ongoing. Very soon it will be the next sampling campaign in Greece. Okay, so last but not least, the presentation titled Development of an Audit Tool for the Certification of the Ecological Rehabilitation of Mined Areas will be presented by Professor Michael Galetakis, and the co-author of the research is Alexandra Gotsou from Technical University of Crete. Please.
Good afternoon, ladies and gentlemen. My name is Michael Galetakis. I'm professor at Technical University of Crete at the Department of Mineral Resource Engineering. And the work I'm going to present here has been carried out by me and by my team. You see their names here. What is the title of this presentation? The development of an audit tool for the certification of the ecological rehabilitation of mined areas. All previous researchers has presented several innovative techniques on how to improve the reclamation of the mined areas. These techniques, along with the techniques that are already used by the companies, make the whole process of rehabilitation. So, there is a big question. All these processes, how will be applied by the companies? How will be organized? How will be audited and evaluating the progress during the time? We need a tool, we need a guide on how to apply this, on how to check this progress of this, and we need also a consistent way to evaluate the progress with the final goal to achieve the better rehabilitation, but also to have the opportunity the company to be certified by a third person, like a state authority, that everything is done in the right way and the company has achieved all the rehabilitation goals. So this is the idea of developing this certification method, and in the core of this certification method is the audit tool that will be presented here. Now, so the challenge is the post-mine landscapes across Europe, we know that remains ecologically degraded. Also, we know that there are a lot of practices by several organizations, but they are fragmented, and there is a lack of harmonized auditing framework. Also, there's a need for a verifiable rehabilitation outcomes to meet the goals of the European Green Deal, as well as with the demand of environmental, social, and geostrategic demands. So based on this, we need a certification system. Now, why do we need a certification system for mine reclamation? Because this certification system supports and ensures the better environmental protection. It also ensures that what we are doing comply with national and European regulations. Because the minimum requirements for a certification system is the compliance with the conformance with the regulations. Also, introduce sustainable practices. It involves the local communities, other stakeholders, and this means that we gain the social acceptance. That is something we need very well. Also, this certification gives an advantage to the company which we are going to apply this certification method compared to other companies. Also helps to acquire mine because financial authority like a bank ask for these certification processes. And of course, it ensures the quality assurance and improvement. The previous presenter has talked about the rehabilitation process, and what I want just to pinpoint that we are on this stage. We are not talking about ecological restoration, as my colleague Lucas said before, because this maybe cannot be achieved within, let's say, a reasonable time period. So we are talking about the ecological rehabilitation. Now, what are the existing certification methods? Because we know that there are already certification methods in practice. The most known is ISO 14000, which is for environmental management system. But this one is mainly for companies from mines that are in operation. It's not exclusively for reclamation and especially for ecological rehabilitation. Also the ISO 26000, which has to do with social responsibility. This is important because we want to involve the social partners in this process. So, as I said before, this existing, they are, let's say, a base where we can use some of their elements for our certification system, but it's not exclusively for ecological rehabilitation. The most recent ISO is the ISO 21795, which was launched in 2021 and specifies how a mine will close in a specific way. This is also another certification method, but it does not deal with the ecological rehabilitation as our. There is kind, let's say, it's not exactly a standard or certification method, it's a kind of guidelines that has been announced by the Society of Ecological Restoration, which focus on these issues, on issues of biodiversity, soil health, and ecological resilience. But this one does not certify companies. Instead, it certifies individuals, practitioners, on how to design and develop such ecological restoration programs. So as we see with the previous certification standards and also the need for social involvement, we see that the component of a modern certification system should include advanced ecological principles, socio-economic integration, stakeholder engagement, adaptive management, because we know that we have an adaptive environment, so every method should be easily adapted to new conditions. We need to confirm with the sustainability global goals alignment, and of course the certification system should be comprehensive, should be easily to evaluate the progress of the restoration, of the reclamation, rehabilitation, and also to provide a way to evaluate the progress. So the solution we propose in the Recall project is the creation of an audit catalog. Audit catalog is in fact the core of a certification system because it defines what you have to develop, what you have to monitor, what you have to evaluate, and gives you a way or how to go on. So this is a comprehensive audit tool and methodology which take into consideration the existing standards and regulations. It establishes measurable ecological indicators and the scoring system, and of course it is adaptable to the local and European regulations. At this moment I would like to pinpoint that this audit catalog is not a standalone document. It must be complemented by local regulations, European regulations, other documents a company or a country is used, because it must be adaptable to each country, to each specific rehabilitation needs to each country. So this, the main characteristics of this audit catalog is that we use a standardized progress. We can monitor the continuous improvement. We can mitigate the risks because decisions are taken into accounting the risk. Ensures compliance with the regulations, address critical ecological aspects, and of course support the sustainability. Now, what is the structure of this audit catalog, which in fact defines also the structure of the certification system? We see that there are 5 parts of this audit catalog, and we start from the pre-rehabilitation assessment, which means that everything we are doing in order to assess the situation before starting rehabilitation. Then we go to rehabilitation planning, how we plan rehabilitation, how we implement rehabilitation, how we monitor and evaluate this, and finally, how we assess the post-rehabilitation assessment. That means what is the success of the whole rehabilitation process. This is each part now, you can see here, has different sections, and you see, for example, that in the pre-rehabilitation assessment, it is the first one. The specific issues that are examined is, for example, the identification of landscape and degradation areas. This is a topic that has been presented and explained by our presenters in this session. The water and vegetation analysis, stakeholder consultation, baseline data collection means that what is our reference system to compare with our situation, and of course the risk evaluation. You see the other items in each part which are included in this audit tool, and of course we have criteria on how to evaluate these specific items, and we use a lot of supporting documents to make all this evaluation, and many of the documents are the deliverables of Recall project. For example, as a previous presenter has said, we have developed methods of how to estimate the degradation of the soil, how to develop indicators for vegetation, and so on. So we use these project deliverables. We use, of course, the international best practices that are proposed by organizations or existing standards. And of course, the expert consultation means that during this project, this audit tool will be sent to all partners, and we are going to collect opinions on how to improve this audit. And of course, each criterion is designed to be measurable. We can measure it easily. It must be relevant to the item that is connected, and they also must be actionable, which means that if we have a deviation from a normal situation, it must show the way we have to act in order to correct the situation. And as I said, this methodological rigor ensures that the tool is reliable, it's replicable in different sites and in different rehabilitation projects. The way we are assessing now each criteria, each item of this audit tool is starting by the lower value, which one? We use a 5-level scale. One means that the specific item what we are examining does not have taken into consideration, or it is very, very low at the beginning of development. Then if there is a significant improvement, we rate by 2. If more improvements need is rated by 3. By 4 means that minimal improvement is needed, and 5 is that everything is okay and no more improvement is needed for the specific item. Here you see some of this, an example of this audit tool, and you see for this the first part of the audit catalog, which has to do with identification of landscape and soil degradation area. And you see here such an example, and also the document which support the evaluator how to evaluate each item of this part of the catalog. And in this case, the main document is the deliverable 3.1, which has to do with the classification of ecosystem degradation, including degraded land maps. Of course, it will be supported by other documents like the Directive for Soils, national regulation, if it exists, and so on. After we have assessed these parameters, you see here just an indicative table showing this, the scores. We can create some kind of dashboard, which means it's a tool where we can easily see the progress we have made in different parts, in different items during first, second audit, and so on. So we can see how the progress is going on and see if we can take some corrective actions. The goal of this procedure is to improve mine rehabilitation outcomes, and for those outcomes to be certified, leading to more mines being successfully closed and rehabilitated to new land uses. And finally, if I want to say, to close this presentation, I would like to pinpoint that the presented audit tool can be applied across coal mines operation of different size and location because it's a flexible tool and it can provide a comprehensive approach that is widely applicable in the coal industry. It uses the European regulation and national law, and this may influence the framework that is applied. That's why there must be a flexible one. It's not provided to be used as a standalone document, but as a guide document in conjunction with relevant legislation, company commitments, as well as with a regional and local land planning scheme. If regularly applied this audit tool, it will allow greater consistency definition of completion and certification criteria, which in turn will facilitate the review of mine closure plans by regulators. And this one, I would say that it is the final goal, to have a certification, and each company should, let's say, be more confident on what he's doing, not only with the regulation authorities, but also with the society. Because we know that the biggest problem at the moment is to accept the social alliance to operate. So I believe that this tool may help significantly in this direction. Thank you very much for your attention. If there is any question, I'm here to answer.
Thank you very much, Professor. It was a very interesting presentation. In my opinion, the audit catalog is one of the main outputs of recall projects. If you are a mine manager, if you are environmental engineer, if you know someone who might be interested in testing this tool or in implementing this tool in mine closure operations and reclamation, specifically ecological rehabilitation, please contact Professor Galetakis or me directly, and we can discuss possibilities of cooperation. That was the last presentation of this session. Yes, Professor?
I would like to add that in the next month we are going to provide all partners and everyone who is interested in this audit tool will provide a link where he can test by itself this audit tool, and we will appreciate if we receive response not only from partners of the project but also from partners from companies if this tool is okay for them, what they suggest regarding its, let's say, its efficiency, if they want something to add, something to change. It will be very, very valuable because we aim to develop a tool that will be useful for the companies. We try to keep it as simple as possible because we know that complicated, very long tools are let's say it's not a favor for the companies. So I will appreciate very much your responses in order to more develop and improve this first version of the audit tool.
Thank you very much. Okay, that's the end of the session. Thank you everyone who joined. Thank you for organizers. Thank you very much.
Zdarzyło się tak, że nie będzie dzisiaj pierwszego referatu od pana Pawola Bożka. Więc przystępujemy do dzieła. Sesja 6. Innowacje w inżynierii mechanicznej i geotechnice. Od modelowania numerycznego po monitoring środowiska. No i w związku z tym zapraszam pana profesora Wieczorka do wystąpienia na temat eksploatacyjnie zorientowane metody poprawy warunków smarowania górniczych przekładni zębatych. Proszę. Ja jeszcze przepraszam, organizacyjna taka informacja. Po sesji o 19:00 kolacja jest poza budynkiem. Z tyłu hotelu, można przejść przez 5. piętro i iść w dół. Z tyłu hotelu jest taka drewniana chata, karczma. Tam będzie góralska kapela, grill i to wszystko, co trzeba, ale tam spędzamy nasz wieczór. Przewidywany czas do 23:00 albo dłużej. Dziękuję, oddaję głos.
No tu mam motywację szybko opowiedzieć. Dobrze. Szanowni Państwo, ja mam dosyć taki specjalistyczny tutaj referat, ale jeszcze przełącznik jakby mógł. Proszę Państwa, dużym problemem w ramach eksploatacji maszyn górniczych, szczególnie przekładni zębatych, jest smarowanie. I nie chcę tutaj może wchodzić za bardzo w jakieś szczegóły, ale przede wszystkim węzeł tarciowy każdej maszyny możemy traktować jako taki system trybologiczny złożony najczęściej z 2 powierzchni współpracujących, otoczenia, które jest zdefiniowane poprzez warunki obciążeniowe, warstwy leżące między tymi, tu akurat nie za bardzo działa może ten wskaźnik, warstwy leżącej między tymi współpracującymi powierzchniami oraz oddziaływania procesów resztkowych związanych z pracą całego węzła. I proszę Państwa, najbardziej korzystny przypadek eksploatacji jest wtedy, kiedy mamy całkowity rozdział współpracujących powierzchni warstwą środka smarnego, czyli to jest przypadek tutaj D. Najczęściej eksploatujemy maszyny w warunkach smarowania elektrohydrodynamicznego, czyli zakładamy ruch tutaj środka, w zasadzie współpracujących powierzchni i w zależności od parametru środka smarnego, obciążenia, chropowatości, ale także prędkości względnej mamy różne warunki smarowania. I parametrem, który definiuje ten rozdział, jest przede wszystkim grubość filmu olejowego, H0 na prawym rysunku, ale to jest tylko jeden czynnik. Wspominałem o chropowatości. Tak naprawdę parametrem, który uwzględnia to jest tak zwana względna grubość filmu olejowego, bo grubość filmu olejowego musi być wyższa tak jakby od chropowatości tych powierzchni. Stąd właśnie lambda, czyli stosunek wyliczonej grubości filmu olejowego do średniej geometrycznej chropowatości powierzchni. Proszę Państwa, ja wykonałem tutaj pewne obliczenia tutaj z tej względnej grubości filmu olejowego dla typowej przekładni typu gwarek. Przekładnia typu gwarek ma różne wykonania w zależności od przełożenia, od od mocy. Różnie się troszeczkę to projektuje, ale powiedzmy, że przyjąłem tutaj obciążenie 132 kW i przełożenie typowe 19 dla przenośników taśmowych. Jaki jest problem w tych przenośnikach? Przede wszystkim są problemy związane z rysami, to może słabej jakości są zdjęcia, ale proszę Państwa, na lewym górnym są pokazane problemy związane z rysami. Pod nim jest, tak powiedziałem, słabej jakości, przepraszam, nie wiem dlaczego tutaj akurat to nie widać na rzutniku, na normalnych zdjęciach to widać. Strefy przegrzania. Na tym prawym górnym są problemy związane z zużyciem ścierny. Na dwóch ostatnich rysunkach jest przedstawione, jak wyglądają po rozłożeniu te przekładnie. Proszę Państwa, sobie pozwoliłem zrobić badania, pomiary w zasadzie chropowatości w zależności od kierunku tutaj szlifowania są nieco inne, wartości będą na kolejnych slajdach, ale tutaj właśnie widać, jak one tutaj, te chropowatości po szlifowaniu przedstawiają się. Ale proszę Państwa, jakie to ma implikacje? Nie chcę tutaj też jakby wchodzić w szczegóły związane z całą geometrią zazębienia, bo to jest dosyć trudne, ale generalnie przy smarowaniu kół zębatych wylicza się 5 tutaj takich punktów. Ja to zrobiłem troszeczkę szerzej, dla 100 punktów zrobiłem i na lewym i widać, jakie są przebiegi tej względnej grubości filmu olewowej w zależności od chropowatości. Na niebiesko mamy chropowatość 0,87, a RA 0,39, czyli tutaj dwa takie przypadki, które zmierzyłem. W jaki sposób uzyskuje się chropowatość powierzchni, to może pójdę tutaj później omówię, ale proszę Państwa, widać, jak znacząco się różnią te wartości w zależności od chropowatości powierzchni. Przypadek bordowy mamy 1 i powyżej, niebieski gdzieś 0,6 i poniżej. Jakie to ma implikacje? Jeśli jest powyżej jedności, to wiemy, że grubość filmu olejowego jest większa od chropowatości powierzchni. Idealnie byłoby, gdyby to było 2, czyli wtedy mielibyśmy 100% rozdział. Tak, jest wyżej, czyli nie powinny się nam stykać te nierówności powierzchni. Przy gorszej chropowatości jesteśmy w warunkach tarcia mieszanego. I teraz sobie pozwolę wrócić sobie na ten przypadek, czyli jeśli jest duża chropowatość, jesteśmy w przypadku tarcia mieszanego lub czasami granicznego, czyli przypadek B i C, a jeśli jesteśmy powyżej jedności, no to już natrafiamy na warunki określone tym rysunkiem D, czyli tarcie płynne. Dobrze, proszę Państwa, kolejny tutaj rysunek, czyli skrajny prawy, przedstawia nam tutaj porównanie wprost tych wartości w zależności na 3. stopniu akurat, bo proszę Państwa, ten, o którym już umówiłem, to był 1. stopień. Na 2. stopniu, proszę Państwa, mimo utrzymania cały czas tej chropowatości pogarszają nam się warunki smarowania i na 3. stopniu też znowu bez względu na chropowatość mamy już warunki smarowania mieszanego. Z czego to jest spowodowane? Proszę Państwa, przede wszystkim tak, im przełożenie wyższe, tym po pierwsze spadają nam prędkości względne, a jednak prędkości względne nam poprawiają warunki smarowania. Z drugiej strony obciążenie nam wzrasta. I to są właśnie czynniki, które powodują pogorszenie warunków smarowania. Na dolnych slajdach pozwolę sobie porównać, tak, przede wszystkim porównanie dla jednej tutaj parametrów chropowatości, jak zmieniają się warunki smarowania na poszczególnych stopniach. Niebieskie to było to akurat dla chropowatości 0,87. Widzimy najwyższe, ale bardzo słabe już są dla 3. stopnia. Proszę Państwa, znowu może słabe powiększenie, ale ten rysunek środkowy, dolny, pokazuje zależności tutaj warunków smarowania od lepkości oleju i mocy silnika napędowego. No i konkluzja jest prosta. Im mniejsza obciążenia, a lepkość jest wyższa, no to warunki smarowania się polepszają. Tutaj podobnie to widać, jeśli mielibyśmy funkcji momentu obciążającego, ale dla różnych dwóch warunków, znaczy dwóch różnych wartości chropowatości powierzchni. Na bordowo to widzimy bardzo dobra chropowatość 0,15, na dole jest już o wiele gorszy. Między tymi dwoma wartościami z reguły się plasują warunki rzeczywiste, które możemy znaleźć w przekładniach górniczych. Proszę Państwa, 0,15, czyli ta bordowa wartość, to jest chropowatość, która jest nam znana z turbin wiatrowych. Tam turbiny wiatrowe akurat, to sobie pozwolę jakby w analogii do wczorajszego zagadnienia, że górnictwo ma przełożenie na inne branże. Tutaj akurat taką tutaj analogię posłużę się. Tutaj technologie wytworzenia związane z przekładniami wiatrowymi wymagają przede wszystkim odporności na tzw. micropitting, czyli zakładają, że warunki smarowania muszą być płynne. Czyli to, co ja tutaj mówię, oni wprowadzają to jako wymóg. Nie może dojść do mikropittingu w czasie eksploatacji przekładni wiatrowych. I to musi być zapewnione przez cały okres gwarancji przekładni wiatrowych, która sięga 25 lat. Miejmy tego świadomość. Są bardzo duże wyzwania związane z przekładniami wiatrowymi. W górnictwie może są inne, mamy inne problemy. Ale proszę Państwa, chciałem tutaj pokazać, że problemy związane ze smarowaniem są istotne. Już wchodzimy troszeczkę w takie szczegółowe wyzwania. Raczej bym kwalifikował mój referat bardziej tak jako pod analizę root, czyli analizę przyczyn awarii, ale już u podstaw. Dlatego właśnie pozwoliłem sobie właśnie na te moje wystąpienie. Co jeszcze, proszę Państwa? Miejmy świadomość, że w warunkach obciążenia przekładni nie mamy warunków nominalnych. Mamy często warunki różne. Tu jest akurat z przekładni z napędu do przekładni i przenośnika zgrzebowego. Przenośniki taśmowe, one może łagodniej pracują w warunkach ustalonych, ale w warunkach załadowania mogą też mieć szybki przyrost obciążenia. No i proszę Państwa, jeśli teraz byśmy takie warunki zmienne przełożyli na warunki smarowania przekładni i do tego jeszcze dodali rodzaj oleju, mamy ten wykres. Proszę Państwa, w zależności od tutaj obciążenia i oleju możemy też sterować tutaj warunkami smarowania, ale mówię o tej samej lepkości, czyli bazując się tylko i wyłącznie na rodzaju oleju, czyli rozróżniamy oleje mineralne bądź syntetyczne, możemy też tutaj sterować. Akurat oleje mineralne dosyć dobrze się w tych przypadkach zachowują. I proszę Państwa, krótkie podsumowanie. Górnicze przekładnie zębate są eksploatowane w warunkach smarowania mieszanego lub granicznego. Dobór środków technicznych związanych z procesem wytwarzania kół zębatych powinien uwzględniać spodziewane w procesie eksploatacyjnym warunki smarowania. Przy projektowaniu przekładni zębatych powinno dążyć się do jednakowych warunków smarowania niezależnie od przełożenia. Możliwe jest zróżnicowanie technologii obróbki powierzchniowej zależnie od stopnia, na jakim występuje koło zębate. Panie Przewodniczący, mam jeszcze minutkę, dwie?
Proszę.
Dobrze. Proszę Państwa, ja jeszcze te punkty chciałem trochę rozszerzyć. Jeśli chodzi o na przykład punkt 3, bo pokazałem, że w zależności od stopnia są różne warunki i wtedy są różne warunki, spodziewana trwałość danej pary zębatej. I jeśli dążymy do jakby poprawy zrównoważonego rozwoju, no to musimy dążyć, żeby każdy stopień, szczególnie ten najbardziej obciążony, miał taką samą trwałość jak pozostałe. Bo w innym przypadku resursy będą inne, ale też nie wykorzystamy w pełni wszystkich możliwości danego urządzenia. I proszę Państwa, jeszcze tak powiedziałem, jeśli chodzi o punkt 4, są różne technologie obróbki powierzchni. Wracam znowu do technologii wytwarzania kół turbin wiatrowych. One, te koła zębate, charakteryzują się, jak już wspomniałem, chropowatością na poziomie 0,15. Uzyskuje się to poprzez procesy tak zwanego superfinishingu, na przykład metodą IFS, czyli takiego jakby dogładzania w warunkach odziewania środków chemicznych. Bardzo drogi proces. Można to zamienić procesem dogładzania kształtkami w pastach szlifierskich. Najprostszym procesem, który możemy tutaj zrobić, to po prostu też zmienić świadomość technologów i zmienić sposób wyboru tarczy szlifierskiej. Bo proszę Państwa, najczęściej technolodzy biorą taką tarczę szlifierską o takim uziarnieniu, żeby proces był najbardziej ekonomiczny. Mamy świadomość tego, że proces szlifowania jest procesem drogim. I jeśli z ich punktu widzenia, to jeśli konstruktor narzuca technologię chropowatość 0,8, no to oni dążą, żeby ten proces był najbardziej ekonomiczny. W momencie, jeśli będzie zapis na rysunku 0,15, no to dla technologa będzie to problem. Ale najprostszym jest zastosowaniem bardzo gładkich tutaj tarczy. One są do kupienia, oczywiście trochę są droższe. To też powoduje, że proces będzie dłuższy. Może koszty będą troszeczkę większe, ale powiedzmy w cenie całej przekładni górniczej, którą liczymy w setkach tysięcy, to może będzie tam maksymalnie 2 do 5% przy takich wymaganiach. Ale zabezpieczymy się przed niekorzystnymi warunkami tutaj eksploatacyjnymi. To moja uwaga. Dziękuję.
Dziękuję bardzo. Czy do prelegenta są jakieś pytania, proszę Państwa? Tak. Proszę bardzo.
Tam z punktu widzenia pańskiego tutaj wywodu wychodziło, że tam najłatwiej uzyskać ten poślizg, czyli tą prędkość względną między poszczególnymi parami kół zębatych, natomiast tam najczęściej dochodzi do uszkodzeń. Na pierwszym stopniu przekładni, a jeszcze gorzej w przypadku, gdy mamy do czynienia z parami stożkowymi.
Bardzo dziękuję za pytanie. Bardzo dobre pytanie. Przede wszystkim tylko, że musimy... Ja tutaj akurat może mało miałem czasu na omówienie kwestii eksploatacji. Jeśli mówimy o uszkodzeniach przekładni zębatych, kół zębatych, skupiłem się na problemach związanych z smarowaniem, ale mamy tak naprawdę drugi problem, związany z wyłamywaniem kół zębatych. I tutaj, jeśli projektuje się koła zębate, to projektuje się ze względu na 3 warunki. Podstawowym warunkiem, który się projektuje, to jest na złamanie kół zębatych, na złamanie zęba u podstawy. I w tym przypadku jest odwrotnie. Koła zębate na pierwszych stopniach są poddawane największej ilości cykli zmiennych. To jest właśnie ten proces, który powoduje wyłamanie zęba. I pan powiedział koła, pierwszy stopień, koła stożkowe. Właśnie tam jest największy problem. Tam bardzo często dochodzi do częściowych wyłamań zęba. Rzadko całe zęby pęka, najczęściej pęka częściowo. Musiałbym trochę wejść w szczegóły, ale głównie to chodzi o to, że bardzo często dochodzi do nierównomiernego obciążenia wzdłuż całej flanki zęba. Tylko koło zębate zamiast całą flanką przenosi tylko częściowo. Stąd właśnie jest ten problem. On jest związany bardzo często z technologią nacinania. Ale znowu też nie chcę wejść w szczegóły, ale to jest dosyć problem, bo kwestia jest przy projektowaniu kół zębatych stożkowa taka, że producenci nacinają te zęby, na te startowają i szukają z reguły śladu na środku. Tak ustawiają, tak montują przekładnie zębaty, żeby ślad przylegania był na środku. Ale pod wpływem obciążenia ten ślad wytarcia, on wędruje. On może być na jednym z krajów. I wtedy właśnie jest problem, który pan wspomniał, że mogą dojść do wyłamywania. Dlatego my mówimy troszeczkę o innych problemach. Zgadzam się, że to, co pan wywołał, jak najbardziej jest problemem, ale w moim referacie skupiłem się na problemach smarowania.
Tak, słychać, teraz słychać. Dziękuję bardzo. Fajnie, że jakaś dyskusja powstaje, proszę Państwa, ale proponuję, żeby wszystkie dłuższe dyskusje przenieść na koniec sesji, ponieważ nam wszystkim czas nieubłaganie płynie. W tej chwili mamy referat pod tytułem Opracowanie metodyki optymalnego doboru parametrów konstrukcyjnych elementów zbrojenia szybowego i pan Krzysztof Rozwadowski nam opowie, nasz komtechowy bohater z Wieliczki. Proszę bardzo. Będzie zaraz.
Albo będzie, jest. Dziękuję panie dyrektorze za przywitanie. No, któraś to już moja prezentacja, bodajże chyba 4. albo 5. Tematu. Już mam nadzieję, że ostatnia, bo tak jak widać mój doktorat dobiegł końca i od powiedzmy końca września już jestem doktorem. Temat to jest kontynuacja tematu, który był przeze mnie prezentowany na tej konferencji już kilka razy, a więc opracowanie metodyki optymalnego doboru parametrów konstrukcyjnych elementów zbrojenia szybowego. Ale pokrótce, żeby nie przedłużać, pójdźmy do konkretów. Gdzieś się przełącza, muszę znaleźć, jest. Wiadomo, Państwo wiedzą, ci, którzy na tych prezentacjach moich byli wcześniej, była to rozprawa w ramach doktoratu wdrożeniowego i w ramach rozprawy doktorskiej została przeprowadzona analiza zmian naprężeń w elementach konstrukcyjnych zbrojenia szybowego, dźwigów elektrycznych. I to jest to nowum, coś innego, nie górnicze wyciągi szybowe, a dźwigi elektryczne, które są w kopalni soli Wieliczka eksploatowane i w tym momencie już przejmują około 60% transportu ludzi. Wykonywane jest tylko i wyłącznie za pomocą urządzeń dźwigowych, a nie górniczego wyciągu szybowego. Ogólnie cel rozprawy doktorskiej, ale cel całego zadania, czyli całego wdrożenia, to obniżenie kosztów budowy i utrzymania urządzenia dźwigowego poprzez zmniejszenie mas elementów konstrukcyjnych zabudowanych w szybie przy zachowaniu obecnego poziomu bezpieczeństwa. I to było całe clue tematu, ponieważ tak naprawdę to wyjdzie zaraz z kolejnych moich rozważań, czyli tutaj analiz podstaw prawnych. co tak naprawdę nami kierowało na etapie wdrożenia tego urządzenia, albo z jakimi problemami musieliśmy się spotkać na etapie wdrożenia tego urządzenia w gór, czyli urządzenia dźwigowego w wyrobisku górniczym. Czyli tutaj z tych dwóch bardzo ważnych ustaw, czyli prawa geologiczno-górniczego i dyrektywy dźwigowej, które z automatu siebie nawzajem wykluczają. Więc wdrożenie tego urządzenia było pewnym kompromisem i tak naprawdę samo zbrojenie szybu było kalką przepisów górniczych związanych z górniczym wyciągiem szybowym, a nie urządzeniem dźwigowym, jaki tam jest zabudowane, a dokładnie jest to urządzenie transportu specjalnego i tutaj mamy profesorów z AGH-u, profesora Rokitę i Kwaśniewskiego, którzy uczestniczyli w tym procesie wypracowania sposobu dojścia do celu, czyli tak naprawdę możliwości zabudowania dźwigu w wyrobisku górniczym. Następna rzecz to jest oczywiście badanie analizy rzeczywistego stanu wytężenia oraz badania modelowe wybranych elementów konstrukcyjnych zbrojenia. Czemu? Bo, tak jak powiedziałem wcześniej, te elementy zbrojenia były przewymiarowane i były dobrane pod górniczy wyciąg szybowy. Tak można to w skrócie powiedzieć. I koniec mojej rozprawy to opracowanie metodyki optymalnego doboru konstrukcji zbrojenia na podstawie otrzymanych wyników z przeprowadzonych badań modelowych i wytrzymałości. To teraz pokrótce tylko przypomnę, bo to każdy wie, ale tak naprawdę o co chodziło w tych analizach podstaw prawnych. Tutaj dyrektywa Parlamentu Europejskiego z 2014 roku, czyli tak zwana dyrektywa dźwigowa, czyli to, na jakiej podstawie te urządzenia zostały wyprodukowane, zbadane i dopuszczone. Następnie dwie normy powiązane bezpośrednio z tą dyrektywą oraz inne normy zharmonizowane i to był ten aspekt dźwigowy. I drugi aspekt górniczy, czyli wiadomo ustawa, rozporządzenie i rozporządzenie dotyczące dopuszczania wyrobów. I tu jest ważna analiza, to o czym już wcześniej powiedziałem, czyli analizy aktów prawnych i normatywnych dotyczących projektowania, produkcji i eksploatacji urządzeń dźwigowych oraz aktów prawnych związanych z prawem górniczym pozwala na stwierdzenie, że w dokumentach tych nie przewidziano w sposób bezpośredni w przypadku implementacji dźwigu w wyrobisku górniczym. Stąd te nasze zabiegi ku temu, by po prostu można ten dźwig w wyrobisku zabudować. Tu są takie konkluzje. Też tak naprawdę to urządzenie dopuszczał kierownik ruchu. Tak naprawdę jest to urządzenie transportu specjalnego, a nie górniczy wyciąg szybowy, czyli jest badane przez rzeczoznawcę, co wynika jasno z rozporządzenia. I tu jest ten taki kolaż dwóch rzeczy. Tak naprawdę kierownik ruchu na zasadzie dobrej współpracy technicznej i tak naprawdę do uzyskania poprawności pracy urządzenia i zachowania odpowiedniego poziomu bezpieczeństwa współpracuje z serwisami dźwigowymi po to, żeby po prostu wdrażać te dobre praktyki, które w dyrektywie dźwigowej są opracowane i można z nich korzystać. Tu jest taki model troszeczkę jak schemat całej tej realizacji, czyli to jest właśnie analiza aspektów prawnych i normatywnych, czyli aspekt dźwigowy, górniczy, o czym mówiłem. Następnie badania mesowskie rozkładu naprężeń, określenie naprężeń w punktach charakterystycznych. Następny etap to badania obiektowe, czyli charakterystyka zmienności naprężeń w punktach charakterystycznych, czyli w tych, których określiliśmy, i potem już sam dobór optymalnej konstrukcji. I teraz tutaj to, co dzieje się już na samym obiekcie. Tutaj jest akurat filmik z przejazdu nie na głowicy, a po prostu na obdachu klatki, bo tak to wygląda. To nie jest klatka, tylko właściwie kabina dźwigu. Tak wygląda przejazd przez ten szyb. I tu wiadomo, część modelowa, czyli badania i analizy rzeczywistego stanu wytężenia oraz badania modelowe. Może to przypomnę, bo część osób z Państwa, którzy nie słyszeli, obiektem podstawowym moich badań jest szyb Regis i 2 urządzenia dźwigowe tam zabudowane firmy Kone, a drugi obiekt badawczy to był szybik Herber i tam o dużo mniejsze urządzenie, ale ono tak naprawdę służyło tylko i wyłącznie po to, żeby wykonać badania referencyjne, czyli sprawdzenie tych moich spostrzeżeń, które były zaobserwowane w Regisie. Tutaj szybko będziemy przeskakiwać, bo wiem, że to już późna pora i trzeba do karczmy zaraz iść, więc przyspieszamy. Przypadek, który był badany, czyli najgorszy z możliwych przypadków, czyli awaryjne hamowanie chwytaczami, pełne obciążenie, pełna prędkość, jedna kabina jedzie w dół, chwytaczek łapią, a w tym samym momencie druga kabina przejeżdża w górę. Tam był po prostu rozkład sił i momentów. Tutaj dźwigar pierwotny, czyli ten wspornik, dwa wsporniki, i tutaj możemy zaobserwować dla wspornika numer 1 to jest ten wspornik po prawej, a wspornik numer 2 to jest ten wspornik po lewej. Maksymalne naprężenia wynoszą od 25 do 40 megapaskali, co jest bardzo niskimi wartościami, nawet jak na ten bardzo niekorzystny przypadek, czyli hamowanie awaryjne. Kolejny etap, po prostu ja musiałem te badania modelowe skorelować z rzeczywistością, czyli określiłem punkt charakterystyczny, który nie jest miejscem, gdzie jest, nie wiem, koncentracja naprężeń, w miarę te naprężenia na mapie są jednolite i według modeli mesowskich wyszło mi, że tam w tym punkcie charakterystycznym, o którym zaraz powiem po co ten punkt, to naprężenie wynosi około 16 megapaskali. I teraz z badań modelowych przechodzimy do badań rzeczywistych. Tam naklejona była rozeta tensometryczna 3 tensometrów rozłożonych co 120 stopni po to, żeby wykonać pomiar rzeczywistych zmian naprężeń. Dokładnie w tym miejscu, gdzie sobie określiłem podczas badań modelowych. I tutaj jest właśnie przejazd i hamowanie awaryjne chwytaczami. Tutaj też muszę powiedzieć, że te próby były tylko wykonywane trzykrotnie, ze względu ja też jako osoba odpowiedzialna za te urządzenia nie mogłem pozwolić na to, żeby tak drastyczną próbę wykonać więcej razy, ponieważ ta próba jest tylko i wyłącznie wykonywana podczas odbiorów urządzenia dźwigowego. Podczas badań rocznych tych prób się nie wykonuje, czyli pełne obciążenie, podparcie prowadnic na dole i wyzwolenie chwytaczy. I teraz tutaj mamy, tam jeszcze miałem jeden tensometr w sporniku bocznym, ale tak właściwie najważniejsze to są te trzy tensometry, czyli 1, 2 i 3, ale tu są naprężenia składowe. proces w ogóle hamowania nie jest procesem, który trwa, on trwa jakiś czas, więc tak naprawdę, żeby rzeczywiście móc zbadać, jakie te naprężenia w tym punkcie wystąpiły, po prostu zwykła statystyka i uśrednienie wartość średnia z wyłączeniem pików maksymalnych to jest 17,4 MPa, a przy pozostawieniu pików 19,1, czyli tak naprawdę jesteśmy bardzo blisko tej wartości, która była modelowana. I to pozwoliło nam potwierdzić to założenie, że ten element konstrukcyjny jest przewymiarowany, dlatego kolejny element konstrukcyjny, czyli model zmniejszony, po prostu przekroiliśmy ten dźwigar przez pół, czyli daliśmy cełówkę 120 i niech Państwo popatrzą, tam jest tylko jedna koncentracja naprężeń, tak to nie przekraczamy 80 MPa, to jest błąd numeryczny, tam był spaw, tak naprawdę mieliśmy problem z zamodelowaniem tego miejsca, a tak naprawdę ten spaw jest wyszlifowany i tego karbu w tym miejscu po prostu nie ma. Co do podsumowania, czyli redukcja całkowitej masy konstrukcji o 59,6%, czyli z 7 ton do 11 ton. Proszę się tym nie sugerować, to są dźwigi, to nie są GWS-y, więc te masy są zupełnie inne. Kosztów niestety nie podam. Wynika to z tego, że część mojej pracy była utajniona i to była decyzja mojego prezesa, że o kosztach się nie chwalimy. Jeśli ktoś chce dowiedzieć, to zapraszam do nas, opowiem. Ale mogę powiedzieć, że to jest w całości inwestycji zredukowanie kosztów od około 7 do 10%. To w zależności od tego, kiedy ten kosztorys był robiony, porównywałem to do kosztów podczas inwestycji i obecnych kosztów, czyli w 2024, bo wtedy. I teraz tu jest cała metodologia, co krok po kroku, co należy wykonać, żeby po prostu móc zoptymalizować, móc zmniejszyć masę tych elementów konstrukcyjnych. Nie ukrywam, że to jest tak zwana ściąga, czy też pewna podpowiedź dla mojego pracodawcy, bo my idziemy w dźwigi, tak naprawdę te dźwigi u nas będą zabudowywane w wyrobiskach górniczych, a nie górnicze wyciągi szybowe, choć na szybie Kościuszko będzie inaczej, ale szyb Paderewski będzie wyposażony w kolejny dźwig, więc tak naprawdę to są kroki, czyli analiza aspektów prawnych, czyli tak naprawdę musimy przeanalizować, co możemy w danym miejscu zrobić, albo na podstawie jakich podstaw prawnych dane urządzenie było zabudowane. Dokonać analizy i określić rzeczywisty stan obciążenia, to po prostu zwykła mechanika. Dobrać metodykę pomiarową, o tym mówiłem już we wcześniejszych moich wystąpieniach. Działamy w szybie górniczym, gdzie pracuje urządzenie transportu specjalnego, więc te metody pomiarowe muszą być na tyle sprawne w montażu, żeby taką rzecz można było wykonać. Porównać wyniki naprężeń w określonym punkcie konstrukcji otrzymane metodami analitycznymi i metodami badawczymi na obiekcie. Po potwierdzeniu zbieżności między wynikami otrzymanymi metodami MES i badaniami obiektowymi dokonać analizy maksymalnych naprężeń otrzymanych na dźwigarzu oraz sprawdzić ich poziom w odniesieniu do RM. W przypadku zauważenia znacznego naddatku wytrzymałościowego dokonać wyboru nowej, zoptymalizowanej konstrukcji. Oczywiście ten element sprawdzić. Celem pracy była synteza prawnych i normatywnych i technicznych wymagań dla implementacji dźwigów osobowych w pionowych wyrobiskach górniczych, ze szczególnym zwróceniem uwagi na aspekty dotyczące doboru elementów konstrukcji prowadzenia szybowego. Jak wynika z mojej prezentacji, cel został osiągnięty. Bardzo dziękuję za uwagę i teraz trochę jeszcze chciałem, z racji tego, że mamy tu kilka osób i z kopalni i z AGH-u, chciałem bardzo podziękować profesorowi Kwaśniewskiemu, który był moim promotorem podczas moich zmagań 6-letnich, kierownikowi katedry panu profesorowi Tomaszowi Rokicie za to, że dzielnie też dzierżył moją osobę, Szymon Molski, który był moim promotorem pomocniczym i kilka chłopaków, którzy gdzieś tam w mojej pracy pomogli, oraz moja małżonka, która dzisiaj specjalnie przyjechała na tą moją prezentację i to, że wytrzymała ze mną te 6 lat męki nad moim doktoratem. Dziękuję bardzo.
Brawa. Proszę Państwa, zanim przejdziemy do dyskusji, to popełniliśmy pewne faux pas wcześniej, bo pan profesor Wieczorek nie dostał od nas braw, bo się wtrącił z dyskusją, prawda? Że brawa również obu panom. Zanim jeszcze zapytam o prosiłbym, żeby nie przedkładać strawy w karczmie nad dyskusję naukowców, bo tego mamy na co dzień mniej niż jedzenia. Przynajmniej nie wszyscy mają możliwość znaleźć się w takim miejscu i w takiej atmosferze, żeby posłuchać. Jednak jakby nie było ciekawych, a czasem dla nas niesamowitych rzeczy. Pytanie do pana doktora. Nie ma. Wykorzystam zatem tą sytuację i zaproszę do następnego referatu. Dziękuję bardzo. Zaproszę do następnego referatu pana profesora Jerzego Kwaśniewskiego, który przeprowadzi przegląd możliwości wykorzystania magnetometrii w inżynierii w kontekście realizowanych prac badawczych i działalności innowacyjnej katedry, jakby pan profesor powiedział, katedra.
Powiem zaraz.
O, tak. Jest to wieloma.
Szanowni Państwo, ale jeszcze ad vocem odnośnie prób badań przez pana doktora przeprowadzonych, bo on tego nie powiedział. Takich prób generalnie dla sfery dźwigowej się nie przeprowadza bardzo często i wyniki, jakie się uzyskuje, są pewną wykładnią. Potrzebne one są niezmiernie przy projektowaniu różnych rozwiązań dźwigowych dla różnych firm w Polsce i nie tylko, bo to są takie bardzo ciekawe badania, które niepowtarzalne, nie mówiąc o tym, że żona tu obecna pozwalała na to, żeby te próby przeprowadzać w nocy, bo tylko wtedy można uzyskać dostęp na tych obiektach turystycznych. A dobrze, ale wróćmy do tego. Szanowni Państwo, Katedra Inżynierii Maszyn i Transportu, kierowana przez pana profesora, obecnego tutaj, pana profesora Rokitę, zawiera pewne informacje o magnetometrii. Coś, co ostatnio bardzo jest modne, więc troszkę powiem króciutko o tych magnetometrach, o implementacji w diagnostyce linii stalowych, czyli w górnictwie, ale nie tylko, bo mapowanie magnetyczne, orientacja w przestrzeni, implementacja czujników w inżynierii medycznej, no ale są oczywiście pewne ograniczenia stosowania tej magnetometrii. Zaraz krótka przerwa. Co się tu naciska? No, trochę techniki. A już jest. Dobrze. Szanowni Państwo, pozwoliłem sobie postawić taką tezę. Magnetometria wspiera zieloną transformację przemysłu w kluczowych obszarach. Te obszary są wymienione na stronie konferencji. To są takie 4 obszary. I chciałem tutaj wskazać na pewne możliwości wykorzystania właśnie tej magnetometrii w tych obszarach. Pierwsze, zarządzanie energią, magazynowanie. Oczywiście te magnetometry mogą mierzyć prąd w transformatorach, rozdzielniach, zasilaniach i tak dalej, a więc kwestia identyfikowania straty mocy. Monitoring pola magnetycznego pozwala na wykrywanie różnych uszkodzeń. To zwiąże się oczywiście ze zmniejszeniem ryzyka. różnych przerw, kosztownych napraw. W drugim obszarze, jeżeli chodzi o zastosowanie odnawialnych źródeł energii, one są wykorzystywane do monitorowania stanu wierników, łożysk, uzwojeń, a więc kwestia przewidywania awarii, czy też wczesne tam naprawy, bo tutaj możemy identyfikować drgania magnetyczne. Kolejny obszar, technologie energooszczędne i niskoemisyjne, a więc te czujniki magnetyczne w różnego typu silnikach. To jest związane z możliwością redukcji zużycia energii i emisji. Monitorowanie pola magnetycznego, detekcji zużycia łożysk, mniej przestojów, jasna sprawa. Kolejny element, cyfrowe narzędzia wspierające zrównoważony rozwój. Te dane z tych magnetometrów mogą pozwolić na tworzenie cyfrowych bliźniaków maszyn, urządzeń. A więc tutaj widać, że to monitorowanie stanu infrastruktury, energii w czasie rzeczywistym to są te możliwości magnetometrii. A więc wpisujemy się w te podstawowe założenia konferencji, o których jest mowa tam na stronie internetowej. A więc tutaj chciałbym zaprezentować troszkę tych rozwiązań, gdzie właśnie je praktycznie można zastosować. Magnetometria, proszę Państwa, definicja na dole, pomiar pola magnetycznego w pobliżu różnych obiektów, pozwalających na wykrycie różnych anomalii magnetycznych. To związane jest oczywiście z uzyskaniem pewnej wiarygodnej diagnozy. W tej magnetometrii są 3 takie elementy ważne. Sam pomiar, cała analiza i interpretacja. Oczywiście my jesteśmy w polu magnetycznym ziemskim, więc to pole magnetyczne ziemskie często nam przeszkadza, a czasami pomaga w tejże właśnie magnetometrii. Zakresy zastosowań oczywiście badania geofizyczne, jest to znane, nauka o materiałach inżynierii, w medycynie, w biologii, w nawigacji, w detekcji, w wykrywaniu ukrytych jakichś metalowych obiektów. No i koniec tych tekstów. Teraz przechodzimy już do obrazków. Szanowni Państwo, typy magnetometrów skalarne, wektorowe. Zarówno jedne i drugie są w naszej dyspozycji. Ja tu nie będę mówił o ich pewnych właściwościach. Co istotne, że do niedawna operowaliśmy w tych zakresach militesli, Tesla, czujniki halotronowe, czujniki, cewki magnetyczne, no różne takie elementy, gdzie poruszaliśmy się w tym zakresie militesli. Natomiast dysponujemy dzisiaj magnetometrami, które mierzą wartości pikotesle, nanotesle. A więc to są już takie bardzo wyrafinowane czujniki magnetometryczne. Oczywiście różny zakres, różne czułości. Oczywiście trzeba było kiedyś je zakupić. Tu pokazuję te przykładowe czujniki, którymi dysponujemy. Ja ich szeroko nie będę omawiał, bo nie mamy na to czasu. Najistotniejszy z nich ostatnio chcemy go zastosować w tak zwanym dual use, tak, czyli zastosowaniach dla wojska i dla sfery cywilnej. To są takie czujniki cezowe pompowane laserowo. W tej sześcianie znajduje się szklana bańka, w której są atomy cezu i one się odchylają pod wpływem zewnętrznego pola magnetycznego i to odchylenie jest rejestrowane. Oczywiście budujemy różnego typu czujniki, takie tak zwane linijki magnetyczne, bo one nam się przydają chociażby do badania lin. Dotychczasowe metody stosowane w badaniu lin stalowych to jest metoda aktywna po prawej stronie. Czyli w momencie, kiedy pojawia się makropęknięcie, mamy informację, mamy zarejestrowany defekt, ale nas interesuje wcześniejsza sytuacja, tak? I tutaj kwestia mikropęknięć pozwala nam tutaj na wykrycie tych mikropęknięć właśnie metoda pasywna, w której wykorzystujemy te super czujniki stosowane w magnetometrii. A więc można podzielić te metody magnetyczne w tych badaniach NDT albo SHM. Tak? Dzisiaj systemy monitorowania są bardzo modne, a więc to są te systemy SHM. A więc metody aktywne, pasywne i hybrydowe. Przykładowo tutaj magnetometria do pomiaru, zastosowanie magnetometrii pasownej do pomiaru pola magnetycznego liny stalowej. Współpracujemy z Instytutem Technicznych Wojsk Lotniczych. Zrobiliśmy taką ciekawą głowicę, która służy do pomiaru właśnie tych anomalii magnetycznych. Oczywiście nie zapominamy o naszej metodzie aktywnej. Po lewej stronie, po prawej mamy pasywną. Więc porównujemy te różne wyniki. Chcemy uzyskać jak największą wiarygodność tej naszej diagnozy. Oczywiście wpływ odległości jest tu bardzo istotny. Stosujemy układy różnicowe po to, żeby uniezależnić się troszkę od wpływu tej odległości. No, przykład zastosowania list pomiarowych w kopalni ruchu Bzie. Stosujemy szereg, bardzo dużo takich różnych czynników wokół badanej struktury, wielokanałowe kontrolery. No, możliwości są olbrzymie, ale pojawiły się oczywiście uszkodzenia w tych liniach chociażby kompaktowanych, gdzie pojawia się pęknięcie, ale nie ma szczeliny. Więc nasza defektoskopia do tej pory stosowana nie bardzo ma miejsce. No, trudno je znaleźć. Tu mamy przykład, sygnał z magnetometru, takiej zamodelowanej linii, gdzie nie ma tych szczelin, ale zmiany są rejestrowane w takiej przykładowej linie kompaktowanej. Oczywiście gonimy pana profesora w liczebności patentów, bo profesor jest dla nas tu wyznacznikiem i gonimy i mamy tych patentów też troszkę dużo w tej materii. Nie możemy być gorsi. Nie. Szanowni Państwo, oczywiście próbujemy odchodzić od metod aktywnych, bo one są uciążliwe, tak jak tu Państwo widzicie, badanie odciągu masztów telewizyjnych. Metoda pasywna, w której będą zastosowane te czujniki magnetometryczne, transportowane oczywiście dronami. W przenośnikach taśmowych też metoda aktywna znana do tej pory. Stosujemy 16-osiowe magnetometry magnetoimpedancyjne. Oczywiście możemy bardzo precyzyjnie określić, która linka stalowa ma swoją anomalię zarejestrowaną poprzez odpowiednie usytuowanie tychże czujników. A więc mamy tu różne obserwatory stanu, które pozwalają na analizowanie stanu technicznego tychże przenośników taśmowych. Proszę Państwa, to SHM, monitorowanie stanu technicznego. Oczywiście odchodzi się od metod NDT do tego SHM. Przechodzimy na to SHM. Jakby Pan mógł nam tam kliknąć ten zbiór po lewej stronie na dole. Oczywiście w górnictwie już to się stosuje w świecie. Mógłby Pan tam kliknąć lewy na dole. System ekspercki SHM w górnictwie. Króciutko i później przerzucimy na drugi. Zarówno w sferze górniczej, jak i w sferze dźwigowej takie systemy się stosuje. Więc proszę zobaczyć, czujniki magnetometryczne stosuje się. Tak? Już dzisiaj nie będziemy jeździć niedaleko. Mam nadzieję, że niedługo dojdziemy do tego, że będziemy stosować tego typu systemy. A ten drugi, jakby Pan jeszcze, również w sferze dźwigowej też takie systemy już są gotowe. No i my też tutaj nie pozostajemy w tyle, więc tu widać metoda pasywna. Dobrze, dziękuję bardzo. Więc pasywna nie ma tutaj żadnych zewnętrznych źródeł pola magnetycznego. Dzisiaj nie ma problemu. Dzisiaj wszędzie jest internet, tak? Ta identyfikacja, monitorowanie stanu zapewnia bezpieczeństwo. A więc tutaj odchodzimy od tej metody aktywnej. Widać u góry urządzenia z magnesami trwałymi, a na dole mamy lekkie, przenośne czujniki magnetometryczne. I takie na przykład w kopalni w Wieliczce też już stosowaliśmy i dalej stosujemy. Porównanie sygnałów nie będę tu analizował. Ktoś może zapytać, dlaczego tu jest taki rozkład, a tutaj inny, ale w kuluarach to może wytłumaczę. Szanowni Państwo, dalszy, czwarty punkt. Ocena integralności konstrukcji. System diagnostyczny łożysk. Znów kolejne jakieś tam patenty. Urządzenie do badania zmian struktury w otoczeniu spawu. Kolejne patenty, kolejne rozwiązania, kolejne możliwości. Przykład realizacji projektu badania dla firmy Centrogum, też na podstawie patentu mamy możliwość diagnozowania stanu kordu stalowego w oponach przywożonych gdzieś tam z hałdy z Niemiec, żeby one nie trafiały na hałdę w Polsce, więc trzeba wiedzieć, jaki jest stan techniczny tego kordu. No więc projekt został zrealizowany. Mamy tu mapę obrazującą stan techniczny tego kordu. Nie będę mówił szczegóły, jakie tam są zmiany. Oczywiście w badaniach ognisk stalowych głowica wykonana z tworzywa z czujnikami magnetometrycznymi. Kwestia odległości czujników, jakieś kolejne rozwiązania się tu pojawiają. Proszę Państwa, nawigacja, orientacja w przestrzeni. To jest też istotne. Tu akurat jest system identyfikujący pojazdy będące w ruchu. A więc mamy możliwość badania rejestracji sygnatur magnetycznych pojazdów. Po co? No po to, że na przykład jak chcemy wpuścić samochód do garażu z butlą gazową, a nie wolno tego robić, no to trzeba wiedzieć, czy ten samochód ma tą butlę gazową, czy nie. Więc tutaj jest kwestia rejestracji pewnej sygnatury, gdzie wyraźnie porównując te sygnatury do samochodu testowego, no bez butli i z butlą, można wyselekcjonować i przerzucić ten samochód w odpowiednie miejsce. Proszę Państwa, autonomiczny robot. Kolejny projekt, który został złożony, czyli tutaj też magnetometrię będziemy wykorzystywać w systemach sterowania autonomicznych robotów. Ten projekt, w marcu będą wyniki. Mamy nadzieję, że uda nam się zrealizować ten projekt, gdzie właśnie tam magnetometry też będą wykorzystywane do diagnostyki. Orientacja w przestrzeni wtedy, kiedy brak jest GPS-ów. I tu jest ten dualizm pewnych działań dla wojska i dla sfery cywilnej. Są problemy właśnie z poruszaniem się obiektów, kiedy jest zakłócony sygnał GPS. Mamy ten system diagnostyczny wyposażony w żyroskopy, w akcelerometry, kompasy i rzeczywiście tutaj, czy to są tak zwane systemy inercyjne, IMU, jeżeli dołożymy do tego systemu magnetometr, mamy hybrydowy system nawigacyjny. Połączenie tego INS-u i magnetometru to jest skutecznym rozwiązaniem w sytuacji, kiedy brak jest GPS-u. Jak drążymy tunel, też mamy zaburzenie, jeżeli chodzi o GPS. Może można skorzystać z tych właśnie czujników magnetometrycznych do różnych tam celów. Proszę Państwa, przedostatnia rzecz, lokalizacja i mapowanie magnetyczne. Standard, wiadomo, już od wieków, bardzo dawno już wykorzystuje się takie właśnie czujniki, jak my mamy, do lokalizacji różnych tam niewypałów, zdalne wykrywanie obiektów pod wodą, również takie możliwości. No i ostatnia implementacja czujników inżynierii medycznej. Zamiast standardowego EKG stosować można takie czujniki, jak tu Państwo widzicie, do rejestracji EKG, a tu jeszcze przykładowe wykorzystanie magnetometrów do sterowania wózkiem inwalidzkim. Oczywiście musimy mieć zaplecze pomiarowe do tego, żeby kalibrować aparaturę, bo jak powiedziałem, te czujniki są bardzo czułe na pole magnetyczne ziemskie. A więc demagnetyzatory, komory antymagnetyczne, różne cewki do celów kalibracyjnych. Ale są również ograniczenia, jak Państwo widzicie, w każdym zdaniu po lewej stronie pojawia się gdzieś tam wpływ pola magnetycznego ziemskiego. No to jest coś, co nam oczywiście przeszkadza. Ale jak wiemy, jakie to pole ziemskie jest, tak jak tu są te parametry, a to są parametry pola ziemskiego u nas w laboratorium, to możemy sobie filtrować pewne informacje i rzeczywiście realizować bardzo dokładnie pomiary. Który magnetometr wybrać? No to odpowiedź zależy od tego, jaki jest cel badań, typ metody, jaki to jest obieg, odległość obserwatora od stanu i tak dalej. Tu wypisane pewne ważne elementy. Warto zapamiętać, żeby Państwo zapamiętali, że pole magnetyczne, czyli magnetometria, są szeroko używane. Pomiar i analiza nie stanowi problemu. Interpretacja wyników wymaga znajomości tych elementów. No i na koniec oczywiście informacja o geometrii obiektu, wiarygodna aparatura, doświadczony personel i odpowiednie algorytmy. To jest wszystko podstawą do tego, żeby uzyskać rzeczywiście rzetelną diagnozy. Dziękuję bardzo. Coś mnie przydusiło.
Wodę, pan profesor.
Jakieś pytania, jeżeli ktoś tam...
Nie musiałem pana profesora zatrzymywać, skończył mu się głos, ale proponuję teraz pytanie, bo po szklance wody na pewno będzie chętnie odpowiadał.
Pracujemy na tym, żeby te systemy zastosować właśnie w projektach, które są za chwilę będą generowane przez sferę wojskową, przez Ministerstwo Narodowej, bo pieniądze z Narodowego Centrum są przerzucane do sfery wojskowej, więc my też musimy się tam jakoś w miarę szybko znaleźć, żeby móc kontynuować.
Tak, żeby funkcjonować, to wszyscy potrzebujemy pieniążków, a tam jest ich najwięcej. Jeśli nie ma pytań, proszę Państwa, to przechodzimy do ostatniego referatu. Brawa były, prawda, dla pana profesora? Nowości aplikacyjne na bazie urządzeń energoelektronicznych. Pan Wiesław Jasina, Jadan, automatyka spółka ZOO. Zapraszam. Proszę nas również zainteresować.
Postaram się kontynuować temat dotyczący innowacji, aplikacji. Dziękuję za prowadzenie. Witam Państwa. Szanowni Państwo, chciałbym troszeczkę również Państwa wciągnąć w tematykę innowacji, rozwiązań technicznych w zakresie bardziej typowych, związanych z napędami, bardziej napędów elektrycznych i automatyką z tym związanych. Firma nasza od iluś lat, prawie 30, funkcjonuje na rynku przesuwamy. Okej, dziękuję. Stres. Funkcjonujemy na rynku dolnośląskim, obsługuje w zakresie automatyki związanej z napędami elektrycznymi, tu przetwornice częstotliwości, falowniki inaczej się mówi. W swoim obszarze, w obsłudze przyszło mi zaszczyt obsługiwać KGHM, w zasadzie wszystkie jednostki, począwszy od hut, a skończywszy na kopalniach ród miedzi. Te nasze urządzenia wdrażamy w zależności od możliwości i zapotrzebowania. Dobieramy urządzenia w zależności od jak gdyby potrzeb klienta. Od samego początku firma nawiązała kontakt, współpracę. W 1996 roku pierwszą jakąś umowę współpracy podniosłem z firmą Danfoss z zakresu prezentacji w zakresie przemienników częstotliwości i tymi urządzeniami, można powiedzieć, przez te 30 lat wprowadziliśmy wiele rozwiązań technicznych w tym przemyśle ciężkim. Oprócz KGHM-u również obsługujemy elektrownie, tutaj Opole, Turów, tego typu rzeczy, kopalnie węgla brunatnego, Turów czy tutaj Konin. Także ta działalność wymusza jak gdyby również pewną postęp i rozwój w zakresie nowych technik napędowych czy automatyki związanej z napędami. Chciałbym Państwa nie tylko dzisiaj może troszeczkę zanudzić, bo na temat przemienników częstotliwości to pewno wszyscy już wiedzą, a chciałbym Państwa troszeczkę wprowadzić, do czego jeszcze również możemy wykorzystać te urządzenia bardziej w takich aplikacjach może innowacyjnych. Ale jeszcze zanim przejdziemy, to takie troszeczkę nasze ostatnie wdrożenia, które dzięki troszeczkę działalności firmy, jako taka firma inżynierska, skupiam w sobie młodych inżynierów z nowymi rozwiązaniami, pomysłami. Udaje nam się podejmować tematy dość innowacyjne, tematy dość poszerzonym w zakresie i od projektu pomocy w zakresie wdrożeń, jak i również wdrażamy te tematy, budując szafy, sterowniki, programując tego typu rozwiązania bardziej kompleksowo, łącznie z wizualizacją czy tematami, które potrzeba skonstruować jakieś maszyny. Mieliśmy przyjemność również modernizować żuraw taki portowy przy Odrze, przy rozładunku węgla w naszej elektrociepłowni w Wrocławiu, gdzie wygraliśmy przetarg dzięki rozwiązaniom innowacyjnym związanym z możliwością już jak gdyby rzutu energii, odzysku energii podczas hamowania rzucamy tą energię bezpośrednio już do sieci, nie wyhamowujemy tego na rezystorach, nie grzejemy tych pomieszczeń na ciepło. Także tutaj też projekt powiązany z wizualizacją, ze sterowaniem, nową kabiną, tego typu rozwiązania. W obszarze takich technik górniczych podjęliśmy się również poważnego projektu modernizacji części maszyny zwałowarki, która jeździ po całym wyrobisku i jest zasilana potężnym kablem 6 kV długości rzędu 500 metrów i tam niestety od iluś lat nie działał poprawnie ten układ nawijania, tego zwijania tego bębna kablowego. Podjęliśmy się tego w układzie rozwiązania poprzez zastosowanie 2 napędów elektrycznych, falowników, jeden z kontrolą momentu, drugi jak gdyby z kontrolą pozycji, specjalne oprogramowania, łącznie z modernizacją mechaniczną całego bębna. Bęben rzędu 3 metrów długości, średnica 2,5 metra. Nie ukrywam, że nawet pod względem obróbki mechanicznej mieliśmy problemy, żeby dopasować czop odnośnie sprzęgła, zamocowania niektórych rozwiązań. Ale rzeczywiście od 3 lat w trudnych warunkach układ się sprawdza i funkcjonuje. Takie tematy mniejsze, kopalnia KGHM-u również potrzebuje do zasypywania jak gdyby swoich wyrobisk, zamulania bardzo dużej ilości piasku. Na 5 pokładach pracują takie stare koparki, które kopią ten piasek i wszystkie koparki, można powiedzieć, udało nam się zmodernizować również pod kątem tego napędu elektrycznego. O, taki jeszcze temat związany z oszczędnością energii, ale może już wróćmy do tematów bardziej związanych z rozwojem i tymi jak gdyby zakresami innowacyjnymi. Do czego można wykorzystać dzisiaj inteligentne rozwiązania, żeby można było tymi urządzeniami typu przetwornice sterować na przykład robotem. Mam taką grupę młodych ludzi, którzy również, można powiedzieć, odzyskali taki zezłomowany robot i wykonaliśmy całą szafę sterowniczą. Wszystkie napędy serwo są sterowane naszymi tymi przetwornicami częstotliwości, tylko tyle, że z nowym softem, z nową wersją oprogramowania, które pozwala sterować tymi silnikami serwo, jak również pozycjonując jak gdyby ten cały układ. Także takimi również działaniami udaje nam się pozyskać jak gdyby zlecenia, aby w jakichś takich prostych aplikacjach móc w prosty sposób, bez oprogramowania fabrycznych korporacji typu Fanuc czy Cook, można było te roboty w jakiś sposób wysterować. Innym rozwiązaniem bardziej koncepcyjnym, które też zostaliśmy zmuszeni do tego projektu, jest wykorzystanie silników elektrycznych liniowych współpracujących z magnesami, które można wykorzystać nie tylko w układzie poziomym, ale również można wykorzystać, można to uruchomić, do układów również sterowania ruchem. Tego typu współpraca silnika liniowego poruszającego się względem magnesów neodymowych, nie ukrywam, jest koncepcja wykorzystania ich do napędu w układzie takich, dzisiaj mówiąc, dużo się rozmawia o magazynach energii. To jest koncepcja magazynów energii tak zwanych kinetycznych, czyli możliwość podnoszenia ciężarów i opuszczania w momencie, kiedy tą energię potrzebujemy odzyskać. Tego typu rozwiązanie mam nadzieję, że się uda wdrożyć z jakimś pozytywnym akcentem przy dużych magazynach kinetycznych. Innym rozwiązaniem są mniejsze silniki liniowe, które można w układach pozycjonowania wykorzystać pewnych ruchów, gdzie też mały silnik liniowy względem magnesów bardzo precyzyjnie poprzez to wszystko jest sterowane przetwornicami, które znowuż mają inne oprogramowania, zarówno do sterowania silnikiem z magnesami, jak i również do sterowania układem pozycjonującym. Bez enkodera możemy pozycjonować napęd w tej nowej technologii, w tej nowej technice. Innym jak gdyby procesem to są silniki serwo, które są do tej pory stosowane w napędach, ale też możemy tymi przetwornicami z nowym oprogramowaniem również sterować tymi silnikami serwo w zakresie różnych aplikacji. Jest tu jakaś woda? Jeśli mogę, przepraszam, troszkę nerwy. Proszę Państwa, innym nowym jak gdyby wyzwaniem dostaliśmy tego typu zadanie, żeby pomóc w sterowaniu nowej generacji turbin wiatrowych, czy również turbin wodnych z zakresu energotroniki, którą trzeba stworzyć pod kątem lepszego wykorzystania, efektywniejszego wykorzystania odbioru tej energii. Na przykład przy turbinach tych wiatrowych jest problem ze sterownikami, które są, no nie wiem, chińskie, jakby to powiedzieć, które mają troszkę... Dziękuję bardzo. Przepraszam. To, co dzisiaj na rynku jest, w większości falowniki chińskie, które okazuje się, że przy tego typu precyzyjnych układach siłowni wiatrowych, pionowych nie dają pewnej efektywnego sterowania. Stąd nasze rozwiązania, które tutaj wprowadzamy, pozwalające troszkę ten temat w układzie energotroniki rozczłonkować, zastosować falowniki, które bezpośrednio tą energię prądu przemiennego zamieniają na prąd stały. Tam jesteśmy w stanie to wyregulować i później z prądu stałego poprzez szynę DC jesteśmy w stanie tą energię wygenerować i ją synchronizować z siecią i przekazać do sieci. Tego typu układy mają większą możliwość w sensie sterowania momentem, czy bardziej efektywnym jak gdyby odbiorem tej energii z takich układów. Nie tylko z układów siłowni wiatrowych, ale również w układach siłowni wodnych, gdzie ta regulacja jest ciągle jak gdyby układem nadążnym. No, nie ukrywam, ten temat też troszeczkę tu koledzy mnie zwiedli, ale to jest taki mały ala, my to nazywamy łunochod. Jest to problem związany z układami pojazdów wielogąsienicowych. Ten pojazd ma 4 gąsienice, no i tu jest problem przy sterowaniu związany jak gdyby z prowadzeniem toru, zwłaszcza przy zakrętach, żeby optymalizować tą siłę na poszczególnych gąsienicach i tutaj wykorzystywać możemy bardzo płynnie układy poprzez przetwornice częstotliwości, które mają odpowiednie algorytmy, które przy skręcie tego typu pojazd łagodnie skręca. Nie ma problemu z pracą tutaj, że część pracuje silnikowo, a część jak gdyby generatorowo. Tego typu aplikacje no, docelowo dziś mamy zapotrzebowanie do dzisiaj rozwijającego się przemysłu rolnego, aby takie maszyny w układzie agro wykorzystywać jako pojazdy autonomiczne. Z takich jeszcze nietypowych może troszeczkę projektów, które ostatnio właśnie teraz na dniach będziemy wprowadzać już jako wyrób, jest na KGHM-ie rozwój sieci zasilającej z 500 V przechodzą koledzy na 1000 V do kilku lat i dzisiaj jest zapotrzebowanie na układy regulujące pompy, wentylatory w sieci 1000 V. Okazuje się, że główni producenci nie mają przetwornic częstotliwości do regulacji napędów. Stąd również moja wiedza i wykorzystując potencjał firm polskiej stworzyliśmy nowe generacje falowniki, które będą zastosowane na dole w kopalni w KGHM-ie. Innym już tutaj na koniec rozwiązaniem z zakresu magazynów energii, dużo się na ten temat mówi. Mamy również pewnego rodzaju takie swoje rozwiązania, patenty, które pozwalają podtrzymać zasilanie dużych, niezbędnych maszyn, urządzeń, przeciwdziałać problemowi, żeby się dana maszyna zatrzymała w momencie, kiedy mamy zakłócenie zasilania danego układu elektrycznego. Możemy zbudować taki układ, kiedy z małego zasobnika prądu stałego, baterii, możemy poprzez specjalne falowniki DC podnosić rzędu tam 8-krotnie to napięcie i wprowadzić to do konkretnego głównego napędu tu przetwornicy częstotliwości na szynę DC i na tej szynie DC podtrzymać cały czas to zasilanie. W momencie zakłócenia głównego zasilania silnika z sieci możemy tą energię wykorzystać z tego małego zasobnika, z tej baterii do zasilania. Układ działa bezprzerwowo. Tutaj również podpowiadam, że zamiast typowych baterii chemicznych, my również u siebie w firmie wprowadzamy element na bazie magazynu takiego z superkondensatorami przemysłowymi. Takie superkondensatory dzisiaj są stosowane w pojazdach, autobusach miejskich jako hybryda i taki superkondensator dzisiaj ma już napięcie 136 V, prąd znamionowy rzędu 157 A, a w piku nawet ten prąd może sięgać do 1,5 kA. To moja wiedza, nie ukrywam, jakby to podsumować, czy firmy budowana jest w oparciu również o podobny proces spotkań, konferencji, tak jak tutaj się odbywa. Również jestem absolwentem Politechniki Wrocławskiej. Zostałem wciągnięty, żeby stworzyć pewną jak gdyby wymianę, platformę, taką konferencję NPP nazywaną. I udało się to nam stworzyć. Dzisiaj mamy taką wymianę między uczelnią a przemysłem tym ciężkim, czyli KGHM, PG, koksownie, cementownie. Przyjeżdżają inżynierowie, pokazują, chwalą swoje rozwiązania. Uczelnie również pokazują pewnego swoje rozwiązania. Tutaj nie ukrywam, silniki z magnesami trwałymi Politechniki Wrocławskiej, pan profesor Zawilak. Bardzo dużo tych jednostek, dużych maszyn z własnej konstrukcji zostało wprowadzonych w KGHM-ie. Zachęcam do współpracy również na tej niwie wymiany informacji na takiej konferencji, gdzie dzisiaj mogę się pochwalić. Również są 4 uczelnie: Politechnika Wrocławska, Opolska, Śląska, Radomska, instytuty naukowe. Jest bardzo intensywna wymiana informacji. Nie ukrywam, że również dzięki temu trochę tej materii mogę Państwu również tej wiedzy przekazać. 7. czy 8. edycja konferencji, bo to od 2016 roku się rozpoczęło. Będziemy mieli w przyszłym roku, w czerwcu, w Kamieniu Śląskim z wizytą. Możliwe, że również uda nam się zwiedzić koksownię Bitala w Rzeszowicach. To tyle. A, jeszcze na koniec jednak rzeczywiście. Troszkę te moje związki z Politechniką Wrocławską od samego początku rozwijała się dzięki temu, że również mam podpisaną umowę, w ramach której studenci do naszej firmy trafiają w ramach praktyk studenckich, a ja również mam możliwość wykorzystać uczelnię, żeby organizować roczne, takie co roku, 2-dniowe szkolenia, kursy na ich laboratoriach. Mogę zaprosić inżynierów z przemysłu, swoje pewnego rodzaju zabawki, takie zestawy konkretne, ćwiczebne, na których automatycy mogą się uczyć konkretnych jak gdyby aplikacji. Tam gdzieś układ pompowy z regulatorem PID, tutaj mamy przenośnik, jak gdyby system, tutaj mamy taki nowej generacji układ wentylatora, który możemy z przetwornicą kontrolować drgania. Tego typu zestawy zwozimy i pokazujemy w zakresie możliwości rozwiązań w zakresie automatyki napędu. To są nasze również takie doświadczenia związane z OZE przy firmie. Mamy siłownię wiatrową w układzie pionowym i tego typu doświadczenia, zabawki troszkę pozwala nam się również wiedzę wzbogacić. Głównym również naszym jak gdyby podstawowym jak gdyby układem dzisiejszej działalności jest obsługa serwisowa, utrzymanie ruchu w tych wymienionych w większości firmach, gdzie grupy serwisowe wyjeżdżają, usuwają awarie, naprawiamy przemienniki częstotliwości. Dużej nawet mocy mamy na KGHM-ie, na hutach, megawatt 200 czy 900 kW, tego typu przypadki awarii mamy możliwość usunąć. Mam również zaplecze serwisowe w kontekście swoich serwisowych falowników, około 20 różnych falowników do mocy nawet 400 kW, którymi w pierwszym jak gdyby układzie działania jesteśmy w stanie podstawić swój falownik, a w tym czasie również naprawić klienta, żeby to się jakoś bez usterki mu funkcjonowało. Dziękuję Państwu za uwagę.
Dziękuję, brawa. Proszę bardzo, czy tutaj do Pana jakieś Państwo macie pytania? Poruszył kilka ciekawych tematów, takich jak magazyn energii. Zawsze mówię, można przez superkondensatory zbierać pioruny, jak mamy, a potem je powoli przekazywać do klasycznych magazynów elektrochemicznych. Jeśli nie ma pytań, proszę Państwa, to bardzo dziękuję i może jeszcze raz dla wszystkich prelegentów duże brawa. Sztuką jest wysiedzieć do tej godziny, tym bardziej, że mamy lekki poślizg. Jeszcze raz powtórzę, o godzinie 19 w tej chacie biesiadnej, nie wiem jak góralska chata, za hotelem KLIMCZOK, można przejść przez 5. piętro korytarzem i wyjść tam z drugiej strony, albo obejść obiekt dookoła, lekko pod górkę. Zapraszam wszystkich, góralska kapela, grill, dobre piwo, pewnie jakiś tam, nie wiem, może wino grzane, nie mam pojęcia, ale będzie przyjemnie, wesoło, a teraz wszystkim już serdecznie dziękuję i spotykam się o 19:00. Dziękuję bardzo.